It was an idea, but nobody
Oh
seemed
yeah,
to care
I
much.
respect you going for it. You gotta shoot your shot. But yeah, it's pretty weird. It creeped me out a little bit.
I can see that.
Hello, I'm MC Toon, your host for tonight. Tonight there's a debate between myself and Alan from the channel Space Audits. Don't know how you audit space, but he does it. It is hosted by Jaron, and the reason why I'm starting a little early is because Jaron starts at 6 his time, 8 my time, 9 if you're on the East Coast. And whatever else. I think midnight if you're in the UK, right? 2 a.m. 2 a.m. Oh. Anyway, I may clip this out and put just the debate up. We'll see how it goes, if it seems useful to do that. So that's the plan. The topic is relativity. Specifically, we're talking about special relativity. 3 topics, 3 parts of special relativity. Linear interferometers, which would be things like the Michelson-Morley interferometers. Circular interferometers were not truly circular, but the ones that enclose a space, like fiber optic gyroscopes and things like Michelson-Gale. And then finally, length contraction, all generally tied to special relativity, not general relativity. So let's see here. I need to get a little pop, little tab going here. There you go. So how are you all doing? I've got a few minutes before we switch over to Jaren's. So we've got the Flat Earth Dweller BUC thinks that I'm a clown. In fact, when I was a kid, my dad had this thing that he wanted to do clown stuff, and I'm like, no. So he tried to interest me in that. Wasn't interested, but I have a cousin. She's afraid of clowns. So her brother-in-law and I would go on Facebook and tag clowns with her face, hoping that Facebook would automatically identify clowns as her and auto tag her. It didn't work. She always untagged herself. Got a super chat from Stringers One, says thanks Titicaca, it's Tunes Day. Thank you for that. I will probably not incorporate super chats into the debate. It's a pretty structured debate, and some people have been posting the links to the PDF. If you're interested, the PDF has the whole format, including all of our citations that we're using. I think somebody, there it is. I'll pin that. There it is, pinned. So Alan and I generated that document together. We set the format together. We sent it over to Jaren and said, this is the format that we want to do. And Jaren's like, all right. So Amadeus Arkham is ready to roll out. Looking forward to the juice. Well, thank you, Axis, for that. This is an exciting one. It is much more formal, much more structured. I like it. And rather than, the dumpster fires are fun, right? When Brian Leakey comes on and goes crazy, that's a lot of fun. But that's not what I want. That's not how this conversation really should happen. And I think Alan and I can have we'll have a nice interaction instead of a dumpster fire. So PhD Tony says, you're talking to someone who can't properly understand trigonometry and discussing relativity with them. Well, yeah. Is this a life choice you're entirely comfortable defending to an impartial audience? I don't know yet if he can do trigonometry. I've not seen him fail at it. I've not seen him run away from math. He does have a better coverage of these topics than most other flat earthers. So we'll see how it goes. But thank you for that, Tony. Professor Parks, PhD, says, in that case, I want to get under the wire. Alan is a good guy, wrong, but a good guy. Yeah, we've had a nice talk. We've several times we've called each other on Discord to set this up and get things figured out. So, yep, it's been good so far. I hope it continues. String News 1 says it's special relativity, so CC took the short bus. Oh, nice. So yeah, Glober Mom, you mean Mathemagic? No. So the site, if you look at the citations, under each topic of the citation, some are mine, some are his. He is citing these things, not just me. So it's not just him saying nah to math. So he's citing things that specifically reference some pretty serious math. I think to a first law of Flurf usage of it. But okay, if you're gonna Flurf, you're gonna Flurf, right? I'm setting up the thing here. You'll see. Well, you'll see how it goes. We'll all see, won't we? Kango44 for 5 New Zealand dollars says, before the relativity talk, does he want to cover something a bit simpler, like how the sun sets? Yeah, and it is funny. Flat earthers want to talk about everything but flat earth. Explain how the sun sets. How far away does it need to be to set? Can't answer that question, then you really didn't get anywhere. Seriously. All right. Yeah. So be looking. I won't say it, but be looking for first law. Just drop it down into the comments here. When first law of Flurf gets used. So Todd Ferguson, Flurfament supervisor, is asking the flat earth dweller, which has more tangents, a circle or a sphere? Ooh. They're tied at infinity, but there are different versions of infinity. So the sphere has a larger value of infinity than the circle. That's a thing. I'm not asking him what his favorite flavor of crayon is. So, Daryl Frost, why special relativity, general relativity has far more to do with the shape of the Earth? So, that's a good question. The first draft had 9 topics or 12 topics, or it was huge. I'm like, we're never going to get through this in an hour and a half. So we set the format. We trimmed it down and kind of put boundaries on it. It should be 34 minutes per topic. And so then we narrowed it down to just special relativity, 3 topics within special relativity, and we have a list of future topics should we decide to do it again. So that answers your question, hopefully. Tim Tully says, 11th law, gotta interrupt a Flurf. Babby Alley, aren't they both continuum so equal in how many tangents to a sphere versus how many tangents to a circle? Well, let me ask you this. How many whole numbers are there? 1, 2, 3, 4, 5, right? How many whole numbers? There are infinite whole numbers. How many real numbers are there? A real number is a number between... First, how many real numbers are there between 0 and 1? And a real number is a fractional part, right? 0.1, 0.01, 0.0001, 0.4. Those are real numbers between 0 and 1, and there are infinite of those. Just between 0 and 1. So how many real numbers are there in total compared to how many integers there are in total? There's a magnitude difference there. And there's a whole topic of infinity like this. It's a strange topic when we start thinking about it. But anyway, I'm a minute out. So Jaron has his intro, which I have no interest in watching. I'm not going to send out his intro. But I'm putting the earbuds in so that I can hear when they start doing stuff. So anyway, let's see. Dara Frost, if the set of odd numbers is as large as the set of odd numbers. Of course it is. PC Tony's getting fancy. He says you can isomorphically map 0, 1 onto negative infinity, infinity. All right. If you say so. And you do say so. All right. I've got my stuff ready to go. Oh, I heard a cough.
All right, mute up and we're gonna get started. All right.
That's Jaron talking.
Okay.
Oh, I didn't have them muted, so if they were saying something and I didn't have the earbuds in, you heard them and not me. I don't know. Oh, Tony Regime, the different values for infinity are called Aleph 1, Aleph 2, etc. Okay. All right. All right, there's the, right there. There's Jaron right there. He's sending nothing at the moment, and there's Alan from Space Audits. So Alan is buds with Witsit, so keep that in mind. Let's see, I gotta finish up this tune shine. I don't know if Jaron is starting his show yet or not. I don't know. Maybe somebody wants to watch him. If you do go over to Jaron's channel, don't be a jerk. If any jerks show up here, don't time them out, because we want to keep their derpitude here forever. So Eric Burns, who is an astronomer, says, I thought astronomers audited space. We see what's going on out there. Yes. All right. Oh, he's starting, but I won't play that. I'm not going to play that. And I'm muted on their side there. I'm sending my video stream though. So Patrick Butler says, I'm not a jerk. I have maximum derp. Thanks, Patrick Butler, who made Water Mountains famous. So Professor Park Species says they kind of don't like Jaron. And Brown Thinker, who is currently in Israel, be careful there, his good friends in Israel, says watching this stream while watching the news is a bit challenging. I'm not going to add another stream. Yeah. Stay safe. Stay safe there. All right. What is our token flurf here, the flat earth dweller? What's he on about? I don't know. Doesn't matter. It's probably not important at all. And just so you know, flat earth dweller, you can send me an email, mc2@mc2.net, and you can come on here and you can flap your face and you can bring all your woke proofs. So good luck. All right, it starts now.
To the moon. Ignition sequence start.
Oh my gosh.
3, 2, 1.
It keeps
Houston,
going.
we have a problem.
All right. I muted myself and them. Yeah, I checked. Medicare is okay. So Medicare's fine.
Welcome back to another episode of Debatism. It's episode number 4. We've got a fun one for you this evening. We've got, first up, MC Tune versus Space Audits. It is the correctness of relativity and Earth's motion. These guys will be going at it, and they've kind of come up with their own format. So it's going to be a little bit different than you might be expecting, but still should be a good time. Let's see if the guys are here. And it does look like they are. Welcome, everybody. We've got MC Tune here on the left. There we go. And we've got Alan on the right. Guys, how are you doing today?
I'm great.
Fantastic. Let's just start out real quick with a quick, just tell everybody who you are and where they can find you and that fun stuff. And then we'll get started. Let's start with MC Tune.
I'm MC Tune. Sometimes people call me Mick Tune, but or you can call me Mike. My channel is MC Tune Live. I have another one, Conspiracy Tunes with a Z. That's where you can find me on YouTube or on Facebook or Discord. That's where I mostly do stuff.
Awesome. Thank you for being here. And we've got Alan. Alan, go ahead and say hello to everybody.
Hi. Yeah. So my name's Alan. I run the YouTube channel @space_audits. You can find me there. I just basically, review and critique, mainstream narratives in physics and the experiments that were done in favor of supporting relativity and all that. So you can find my channel there and more about the work and stuff that I put out there.
All right. Thank you very much for that. And let's get going. I'm going to get your layout right now, but do we need to do a coin flip first, or do you guys already decided that?
We decided who goes first.
Okay, great. Go ahead and who is first? I believe it's Alan, correct?
It's on the notes we sent you, Jaron.
Yes, but I don't have them in front of me. That's why I'm asking you.
It's all right. I'm first on the presentation, the 10-minute.
You're first. All right. And I will have them up here quickly so that I don't do that again for you.
It's all good.
All right. And okay, I believe that's it. We're ready to go when you are. And I will set the clock in 1 second. I'm not going to dare ask you how much time to put on the clock. Don't worry. I will not ask that.
Good luck. Good luck, team.
Yeah, have fun, guys. And try and not step over each other. That's all you can ask.
All right. Awesome. So the first topic within special relativity is linear interferometry. From the 1600s to the late 1800s, a large number of experiments informed people about the position of the Earth in the universe. Romer measured the difference in eclipse timings of Jupiter's moon to be varying annually. 11 to 12 minutes, it varied. James Bradley measured aberration, which varied based on the position of the star in the celestial sphere. Vogel and Schneider measured the change in color of light from fixed stars. That varied annually. Frederick Bessel measured stellar parallax, which varied annually as well. So all these different things that people explored and experimented on helped us to understand the position of the Earth in the universe. And all of those experiments, of course, were not just done once. They were done over and over again. So they're repeated, an important part of science. In the 1800s, there was an ether hypothesis for how light traveled. They thought that light traveled as waves through the ether. And people were using the knowledge of the Earth in the universe as one of the tools to test how light works and if it interacts with a hypothesized ether. One of the early ones was George Biddle Airy. It's sometimes called Airy's failure. In the conclusion, he concluded that Klinkerfues, who was one of the people that was hypothesizing it, Klinkerfues inferred that the angle of refraction would be influenced by the motion of the Earth, and he attempted to detect the inferred effect. The conclusion was, I think myself justified in concluding that the hypothesis of Professor Klinkerfues is untenable. So the ether hypothesis was hit a roadblock there. Then Michelson-Morley, the famous Michelson-Morley that we talk about a lot, tested for ether using the Earth's orbit around the sun. The conclusion of the experiment is that they did not find the predicted effect based on the orbit of the Earth through the hypothesized ether. This was repeated many times over the years. Michelson did it several other times. Kennedy, Thorndike, Illingworth. But this disagreement between the hypothesized ether and experiments caused what Thomas Kuhn calls a crisis in the model. If you've read Thomas Kuhn's work on science, scientific revolutions, almost said revelations. This is where newly found information contradicts an established model. A model must incorporate all observations. When a large number of disagreements are unresolved, this is a problem. As the disagreements add up, it prompts what Kuhn calls a scientific revolution. And Einstein, in 1905, his paper started that scientific revolution. But some people did not agree with that. And like good scientists, they did more experiments, as you should. If you disagree with something, go do more experiments. See if you can do some better science. Dayton Miller was one of them, and he got the same apparatus that Michelson and Morley used. He enhanced it, did tests for several years. He concluded that he did measure the ether wind. He did extensive geometrical analysis based on the location of the measurements, Cleveland, Kansas City, Mount Wilson in California, the three-dimensional location on the globe, the time of day to apply the position of the rotation of the Earth, and the time of the year to apply the position of the Earth around the sun. He said, this gives for the first time a quantitative determination of the absolute motion of the solar system and a positive detection of the effect of the orbital motion of the Earth by means of the ether drift interferometer. Then he also said, this is the final solution. This is as he's coming to the end of all of his analysis. This is the final solution for the cosmic component of the motion of the Earth and is the absolute motion of the solar system as a whole. This cosmic motion of the Earth has a velocity of 208 kilometers per second and is directed to the apex, having a right ascension of 4 hours and 54 minutes and a declination of negative 70 degrees, 33 minutes. Then we jump forward to 2004. Hector Minera published a paper where he claimed that all previous interferometer measurements were invalid because he said they did not count the full fringe shifts between individual measurements. So he said that they set up their device, they did a measurement, they rotated it, but they didn't watch the fringes change while they rotated it. And when it got to new position, he says they only recorded the fractional position of the fringes. They didn't get the full fringe shifts between positions, and that left off a bunch of data, he says. And when you do that, if that's what did happen, then basically you're just going to have random numbers because you're missing the most significant digits. You just get the fractional portions, the deeper significant figures, and that just basically is a random distribution without the more important numbers. Anyway, so he said you have to use them. So he calls it, when you constantly do this, he calls it a dialeptometric measurements. Now, he made up that word. I don't know if I'm pronouncing it the way he pronounces it. He speaks Spanish. He said it was from Greek. Who knows? But it just means continuous. So that's really what it means. So basically, if you only record the fractional part, ignoring the whole part, you get random data. And so he would have to reject Dayton Miller. He didn't say specifically if he did that. I saw maybe he did, but he definitely does not approve of Michelson Morley. So he used his own device like Michelson Morley. He used a camera to take photos of it and wrote some software to read the magnitude of the shift. Like Dayton Miller, Hector used the position of the experiment on the surface of the globe, the position based on daily rotation, and the position of the Earth orbiting the sun to do his analysis to reach his conclusion. Page 87. Now, if you have the PDF with all the citations, you can find the citations in there from, anyway, page 87. He said, from the previous quantitative analysis, it may be said that the solar motion consistent with our observations may be in the range 300 to 360 kilometers per second, with right ascension from 170 degrees to 190 degrees and declination between negative 45 and negative 50. You compare that to Dayton Miller, if you accept Dayton Miller or not. Dayton Miller said 208 kilometers per second, a big difference. And a right ascension of 73 degrees versus 170 to 190, very different. And a declination of negative 70, very different from the Hector Minera value. So there is no agreement between those two particular analyses. But if you take Hector's claim about previous recordings and probably then reject Dayton Miller, then you have just Hector's observation standing alone as the only one without any repetition. So he does make some good points about these continuous measurements, but I couldn't help but notice that he didn't mention anything from LIGO, because LIGO is an interferometer significantly more precise than any other previous interferometer. And it is continuous. It is a dileptometric, as he would say. So I actually emailed Hector to see if he had addressed it. He hasn't responded to me yet. So anyway, the problem though is that Hector and the others, all of these things have been greatly improved on since then, even since what Hector did in 2002, 2003 in LIGO, and in other things like Holger Mueller's modern Michelson-Morley experiment using cryogenic optical resonators from 2008 found that no ether wind at the 10 to the negative 15 level, or Eisel's laboratory test of the Eisel's, I don't know if that's his name is being pronounced correctly. Anyway, the experiment is called Laboratory Test of the Isotropy of Light Propagation at the 10 to negative 17 level. It's from 2009. So when I look at the broad number of different interferometer tests, the few outliers like Dayton Miller and Hector are outliers. They're interesting to look at, and maybe they are the true one, the one true truth of how it works, or maybe not. When looking at all of them, I tend to want to see the ones that are in agreement with each other. Those have more scientific value than the ones that are the outliers. There may be an error, a systematic error in what they did. It's hard to say exactly, but I'm going to go with the better, newer experiments instead of the outliers. There you go. How's that? Hit 10 minutes right on. So then I have then
30-second question, right, for him?
Yes, I do. All right. The question is, and if you're looking at the PDF, it's already in there. Preface, both Miller and Munera performed thorough geometric analyses on the measurements to determine the direction of the ether wind based on the rotation of the Earth, position of the Earth's orbit around the sun. They concluded that the solar system is moving towards a specific point in the south celestial hemisphere. The question is, do you accept this analysis, or have you done independent analysis for your hypothesized Earth geometry?
Okay, my turn to respond.
Yeah, you got a minute and a half.
All right. I do not fully accept the analysis of the direction of motions as presented by Munera and Miller, as if if the motions were true, the fringe readings would be stronger. Thus, the measurements themselves say nothing about the motion of Earth. That is the interpretation of the heliocentric axiom based on, or how they interpret the fringe scales, basically for the amount of motion, like 5 kilometers per fringe, etc., that sort of thing. That's all based on Michelson-Morley's scale. So, as a motionless Earth would invert the interpretation of the assumed direction of motion of Earth through the solar system in relation to the celestial sphere, it would as well invert the ether wind effect. So it would flow east to west following sidereal time. So eastward propagation, the speed of light would be c minus v, and then for westward propagation, it would be the speed of light plus v. So c plus v. And I do not fully accept their analysis in that regard because of the scale of interpretation, which I talked about earlier. And Munera followed that arbitrary scale, which is the mistake that all these guys make when they do their measurements and comparisons for linear interferometry, because as it will be shown later in the debate, that the full motion would be detected irrespective of a linear velocity or rotational, and only one matches sidereal time with no relativistic corrections. Okay, that's all the time I need.
Okay, thank you very much. And if people want to follow along with the format, you can go to the link I put in the chat. I'll go and put it in the chat again, and I'll also put it in the description if you want to follow along. Up next, we've got Space Audits giving a 10-minute response to the topic, correct?
Yes.
Your clock is ready when you are. I'll start it.
See, can you bring me up on full screen? I got like some slides to go with it as I talk, play in the background. Is that
Yeah,
possible?
you mean
Or is that gonna
you're
mess
going to
up the
share screen?
formatting?
Yep.
I was just going to do it straight from the webcam with OBS. So if that,
That should be fine. I can bring you up on a separate sheet, I think, or a separate page.
all right, very cool. All right. All right. Linear interferometry, the genesis of special relativity theories. The genesis of special relativity. The genesis of Einstein's special relativity theory is primarily focused on the Michelson-Morley experiment. The experiment showed a positive confirmation for an etheric framework as it showed a variance in the speed of light, while simultaneously providing a negative confirmation for Earth's orbital velocity. The variance in C would have been proportional to Earth's orbital velocity relative to the ether had the orbital velocity existed. This sentiment is the importance of this sentiment of Michelson-Morley is expressly noted in Einstein's private letters to Malavia in his 1905 publication. In an interview in 1963 with Shanklin, Einstein was asked how he heard of the Michelson-Morley experiment, and he said, "I became aware of it through the writings of H.A. Lorentz, but only after 1905. Otherwise, I would have mentioned it in my paper on the electrodynamics of moving bodies." Contradictory to that, in a letter dated 28 December 1901, Einstein writes to Malavia, "I want to get down to business now and read what Lorentz and Drew have written about on the electrodynamics of moving bodies." Referencing Lorentz's 1895 publication, Attempt at a Theory of Electrical and Optical Phenomenon in Moving Bodies, and Drew's 1900 book titled Textbook of Optics. Also of note, in Drew's book in chapter 8, he mentions that he's adopting a stationary ether framework because of Lorentz's complete and elegant theory, which is the basis of his work. In the very same chapter, Drew goes into great detail of the Michelson-Morley experiment of 1887. In a letter dated 28 September 1899, Einstein writes to Malavia again, "I read a very interesting paper from Wynne in 1898 on this subject. Wynne's paper, referenced by Einstein, contains a list of experiments that gave a negative result for Earth's motion relative to the ether. Michelson-Morley experiment of 1887 was on that list, as well as Airy's failure and a couple other ones." Anyway, let's see. Okay, yeah. So, quote from Wynne's paper concerning the translational movement of light atoms. "The negative result is incompatible with the assumption that the ether is at rest. In this assumption, it can only be maintained as a hypothesis that the linear dimensions of rigid bodies are altered by the motion through the resting ether as by the same ratio to compensate for the lengthening of the light path. Here we see the source of Einstein's mathematics, i.e. Lorentz symmetry, which the special theory's first postulate explicitly adheres to, as is the basis of his and the basis of his second postulate regarding relative motion and the speed of light and the ether coming from the work of Drew, Lorentz, and Wynne. Now that the history and the genesis has been established of the importance of special relativity and its framework to interpret Earth's motion, let's now get into the history of interferometry, starting with the Earth's orbital velocity and the linear motion thereof. Michelson-Morley 1887, an orthogonal armed interferometer with one arm aligned to Earth's assumed direction of motion and one perpendicular to it. The variance in C shown in the experiment was co-opted via length contraction and time dilation as an explanation as to why the French shift was shown without producing a reading proportional to a velocity of 30 kilometers a second. Next, Dayton Miller, 1905 to 1930, using a slightly larger interferometer than Michelson's original, conducted 30 years of experiments, taking over 5,200,000 measurements, where he showed a fluctuation in the speed of light when that data is plotted against sidereal time. The fringe shift patterns reach their minimum and maximum dimensions on the days of the equinoxes, on the exact day. During Miller's extensive work with his controlled experiments, which include varying heat sources, varying materials used for shielding, varying the location of the apparatus in a basement at altitude, etc., and much more, between 1922 and 1924, Miller conducted his most rigorous controlled experiments, constructing an entirely new apparatus out of materials that would minimize mechanical, magnetic, and thermal effects. In an independent analysis of Miller's work from Maurice Elias and James Demio, they confirmed that Miller's data reaching the minimum and maximum dimensions on the fringes when plotted against sidereal time shows the corresponding change in the speed of light. When plotted against diurnal time, no meaningful insights present themselves, meaning the day-to-day weather temperature fluctuations did not change anything. or it didn't affect anything. An analysis done by Shanklin and others was only conducted on the diurnal comparison, not a single mention of the sidereal. Moreover, Shanklin and others cherry-picked Miller's work to discredit him. This is noted by the selection of data sets used in their analysis. Throughout Miller's entire body of work, there are only 2 days where the fluctuations matched diurnal time, and those were used as long as a third data set that was selected from Miller's unpublished controlled experiments, where he was purposely forcing the apparatus to give a zero reading. Shanklin's profound insights into Miller's work, which are akin to a hand-wave dismissal, was that Miller did not know about temperature differentials and how that would affect the readings. So this is obviously contrary to Miller's entire body of work. It should be noted that while Dayton Clarence Miller was alive, no man could refute his work on interferometry in the ether. It was stated by Einstein that if Miller's work were to be reproduced, that his entire theory of relativity would collapse like a house of cards. Here's some people who have reproduced Miller's sidereal measurements. Yuri Galev, 2001, ethereal wind experience and millimetric radio wave propagation. Yuri Galev again in 2002, measuring ether drift velocity and kinematic ether viscosity within optical radio bands. Hector Minera, 2006, during a 2004 periodic fringe shift of a continually running stationary Michelson-Morley apparatus. And also in 2004, it was experimentally shown by Ruyang Wang and others that the Sagnac effect persists in a non-rotating inertial frame using a fiber optic cable configured as a conveyor belt. Additionally, there was a linear cable attached to, or a fiber optic linear motion sensor attached to a pulley on the conveyor so that it would experience its own linear motion along with the conveyors, and they both gave the full reading for the exact amount of linear motion. Wang and others showed that the propagation of C in a straight fiber optic cable in inertial motion produces a fringe that corresponds with a first order dependence of the fiber optic cable's linear motion, just as the rate of C has a first order dependence on the angular rotation of a fiber optic cable in a rotating apparatus. This means that if Earth were truly moving, the full linear velocity would be measured without invoking relativistic corrections. Additionally, Wang demonstrated the mathematical equivalence between the circular derivation of the Sagnac effect and its linear counterpart, including the circular predictions and the linear equations. The circular equation is as follows: delta t equals 4 times omega times a over c squared, where omega counts for angular rotation, angular velocity. And for the linear equation that Wang used, he's got delta t equals 2 times v times L over c squared, where v is the linear velocity. The important thing to note here for velocity's sake, or for simplicity's sake, is that the two equations use different symbols to represent different types of motion, even though they were shown to be completely equivalent. The experiment shows the following. Interferometry can be used to detect linear motion with nanoscale precision. If the Earth were truly in motion, the Michelson-Morley experiment would have produced a greater fringe. This removes the justification for accepting Einstein's use of Lorentz transformations to explain the lack of motion under the mechanism of length contraction and time dilation. Special relativity is fundamentally rooted in the perception of uniform linear motion and how it cannot be detected due to so-called relativistic effects. This has been shown to not be true. The Sagnac effect is a classical effect, not a relativistic effect, which will be touched upon more later. Without the explicit explanation of angular rotation, relativity has no answer for the variance in C. Where am I at on time, Jaron? 2? Okay. Let's see. So linear interferometry there, showing that it's completely equivalent to circular. So the separation between the two is actually kind of a misnomer. The velocity, whatever the velocity is, it reflects a first order dependence on the fringes. Or I'm sorry, the fringes reflect the first order dependence on whatever the velocity is. Doesn't matter if it's linear or circular. And that's all the time I need. And then I could just read off my question here and then you can answer, Toon.
Sure.
Okay. Preface. As it has been experimentally verified by Wang and others in 2004 that linear velocity contributes to the full fringe displacement with nanoscale precision, as it does with angular rotation throughout the history of interferometry, Michelson-Morley, Yuri Galev, Miller, Minera, etc. When the variance in the speed of light is measured that corresponds to sidereal time, only a measurement that corresponds with sidereal time, hold on, I whiffed that hard. Okay, throughout the history of interferometry, Michelson-Morley, Yuri Galev, Minera, and everyone shows a variance in C that corresponds to sidereal time, i.e. the rotation of the sky where their fringes reach the minimum and maximum dimensions in accordance with the equinoxes. Okay, so question. Knowing the linear velocity produces a fringe of a first order dependence on the velocity and it only matches fluctuations corresponding to sidereal time, how do you justify the second order corrections of length contraction, i.e., second order corrections of relativistic effects, i.e., length contraction and time dilation to supplement the missing orbital velocity when the same corrections are not applied to give measurements that give agreement with sidereal time, like Michelson-Gale, et cetera, which we'll kind of get into in the next one, but is what it is. Okay. That's all I needed.
Yeah. All right. So to answer that then, I disagree with the statement that throughout the history of interferometry, a variance in the speed of light is measured that corresponds to sidereal time. That's not found in LIGO. That's not found in the newer measurements using Michelson-Morley type interferometers. So I don't agree with that. There's a large number of citations that we can look at that don't show that. So I don't have that. I don't have that to be the case. I don't accept those outliers that you're talking about. So the first order dependence on velocity, I don't agree with that. So second order is different depending on the apparatus. So yeah, we'll get into that, I'm sure. But yeah, length contraction and time dilation are different effects and things that are not observable in Michelson-Morley type apparatus.
Okay. And that was your response. So now you both get a 10-minute exchange. So whoever wants to start that out, it's fine by me. If anybody's interested in asking either of these guys questions, you can send in super chats if you want, or tips on Rockfin. So go ahead, begin, and I'll bring. You want to put yourself back on the screen, or are you going to be showing your screen there on? It's up to you.
Yep. Give me 1 sec. Turn that off, and then webcam. There we go.
Beautiful. All right, starting the clock. 10 minutes. You guys are free to discuss.
Okay. You want to kick us off, Toon?
Sure. So, why not look at the newer measurements of Michelson-Morley type experiments like LIGO and other ones?
Yeah. So during Miller's career of interferometry, he did an insane series of controlled experiments where he figured out all the variables that would give, lesser readings, null readings, etc. So what they do in modern interferometry is they're basically following the handbook of Miller, where they're changing the arm length of the apparatus, they're adding different mediums to the path that the light's propagating through, and they're changing the sensor location, and they're also doing it in a basement, concrete, steel walls, etc. So all these factors, Miller explicitly figured out that they contribute to a trending towards zero trend. And that's the modern interferometries are not analogous in that regard, even though the equipment's more high tech, more sensitive, etc. They haven't accurately reproduced it analogous to the way that it was done originally, the way that Miller did. How
does LIGO not surpass the quality that Dayton Miller did?
Well, whatever LIGO attempts to measure, like they're not going to talk about an ether wind, like you know what I'm saying. So like, I don't understand the relevance of your question in regards to that. So okay. Hold on one second. Sorry, let me respond. I got you. So the way that they would interpret a fringe displacement, right? They would zero that out. They would zero that out as an error. They wouldn't acknowledge that from their interpretation because they're already in the relativistic paradigm. So they're not looking for a fluctuation in that regard. They're looking for a computer to say, hey, we registered a slate, fringe displacement the width of a proton, right? So it's like I see what you're saying, but it's not really analogous in that regard.
Well, if it was, in the instrument that Dayton Miller was using was significantly less sensitive than LIGO, and he was supposedly able to measure some magnitude of ether wind, LIGO definitely is going to be able to measure that. But you say that Dayton Miller, and Dayton says that he measured a constant varying amount, and that's what Monero said. Monero also said that it was constantly varying. So LIGO is also going to measure a constant varying amount, and you can't just zero that out. It's constantly varying. It has to, because that's the claim of the citations that you have there. So how is it that they're not, because it's if they can do less than the size of a proton, that's significantly larger than, it's orders of magnitude
Gotcha.
compared
Gotcha.
to Dayton Milton.
Okay, gotcha. The claim that they can't zero it out because it changes, at a fluctuation that's slightly unpredictable is an insufficient claim, because atomic clocks actually go out of sync in the same regard, and they're able to account for the same kind of synchronization errors. So it's not a sufficient answer. They would absolutely be able to detect that, register it as an error based on their metrics that they have established. They actually have like false positive metrics set up. So when they get a fluctuation reading like that outside of the confines of their system, yeah, they're 100% going to ignore it without question. It's not even going to register to them. They're only looking for their computer to send off an alarm that says that they detected gravitational waves.
Except it's constant varying, right? That's what Monera said. It never stops. So it's not.
Are you aware
it's
of
not
how
like
an atomic clock works, my good sir?
Yeah, it's not an atomic clock. So it's
same
fringe,
same fluctuation.
Yeah. An atomic clock has small up and down.
Unpredictable.
Yeah, small up and down fluctuations.
It's completely accountable.
Yeah,
atomic clocks oscillate at 14 billion times a second, or I'm sorry, 14 billion times a second. So like it's definitely within their range to fix that and calculate it.
Yeah, but you're saying that this oscillates once a year, and that it's a constant fluctuation that's always happening.
It fluctuates on the equinoxes.
Well, yeah, it peaks on the equinoxes.
It reaches their minimum and maximum dimensions.
Yeah. So it's not 14 million times a second. It's twice a year. So, but it's constantly shifting by your claim. So, all right. We're going in circles here.
Yeah. Let's proceed on. So okay. I got a couple for you if you don't mind.
Sure.
Or wait. Is this your cross exam?
No, it's just open chat.
Okay. Yeah. Okay. So in your opener, you talked about some stellar aberration stuff, which we can touch on at the end because I want to stay primarily focused on the relativistic stuff. Let's see here. Gravitational waves, R&D distribution. Yeah, dude, it's crazy when you take notes in shorthand and then you read them later and you're like, I have no idea what any of this says.
Scribble, yeah.
Yeah. So you said, okay, so let's cover Michelson-Morley, or let's cover Airy's failure real quick. Well, because I can't make out the other notes. Let's cover Airy's failure real quick.
Okay.
We got, let's see. Share screen, monitor. Michelson-Morley. All right. So in regards to Airy's failure and all that, that's in regards to a specific stationary ether theory. So an important thing to remember here is that all these different various ether theories.
This is Michelson-Morley.
Yes.
Okay.
Yeah, he has an excerpt here about Airy's failure at the end with the explanation in regards to a stationary ether theory, which is what's producing the conflict, right? Because if the Earth were in motion, then yeah, it would present a problem because the light would have had to go in the opposite direction of Earth's motion to account for it. So blah blah blah, right? So with a stationary Earth and an ether wind theory, that's completely compatible. Yeah. So there's an answer for that for Airy's failure in regards to that. Yeah. Continue.
Well,
or did you want to interject?
If there's, Airy's failure, I don't know if it was repeated ever, but if there is an ether wind, wouldn't Airy's have picked that up? Or maybe it might not be sensitive enough.
Yeah, there was a slight variance.
Okay.
It's just, not very big, not outside of the confines of the heliocentric prediction of Earth's motion with respect to a stationary ether. So.
Okay.
All right. And then let's see here. The relative effects. So you said no relativistic effects were shown in the Michelson-Morley, or that that time dilation and all that was insufficient for Michelson-Morley.
Well, no, I said that relativity doesn't suggest that Michelson-Morley should be picking up any movement.
What do you mean by suggest? It was explicitly invented to reverse engineer, so to speak, the amount of orbital velocity that was missing from the wrench displacement. Oops, sorry, I can share.
Yeah. The point is that within relativity, there's no expectation that a Michelson-Morley interferometer would pick up linear motion.
Oh, well, it doesn't matter if what special relativity says about that. In classical mechanics, which was before that, and the theories that preceded special relativity, fully predict that and show a measured motion in correspondence with that, where there is a variance relative to the angular velocity or velocity with a first order dependence.
Yeah. So that's, I mean, that's the thing in question is the, like Thomas Kuhn's, the model is accumulating too many discrepancies. So the classical mechanic model is just getting those discrepancies. And so then special relativity came along, and that was the impetus for the scientific revolution.
Well, there was no discrepancies with classical mechanics. The discrepancy was with trying to find or to extract Earth's orbital velocity out of a situation where there is none.
Well, no, the discrepancy is that the four things I listed at the beginning, Romer, James Bradley, Vogelschneier, and Bessel, and other things had specifically identified that the Earth is moving. So that the Earth is not moving.
Let's knock that out real quick then. Okay, so stellar aberration can be plotted against the sun following its ecliptic. So how they say that the little tiny arc that all the stellar aberrations make, and if you ratio that to the speed of light, comes out to 30 kilometers a second. Do the same thing with respect to the sun. It's exactly the same. So following a neotectonic Brahe model, a neotectonic model, it would be the exact same. What was the other one? What was the other one?
So you have a citation for that somewhere, or is this just?
Yeah, I do. Yeah, okay. There's a book called Galileo Was Wrong, the Church Was Right by Robert Sungenis and Robert Bennett. Robert Bennett is a PhD physicist who's retired now, and he did all the work on mathematically showing exactly what I'm talking about, modeled it out. Yes. So if you want to see it, I can provide that to you. So yeah, okay. he did that, showed that. It is absolutely 100% a valid explanation to map it against the sun, and it would show the same effect. And then, so you said light color in stellar observations. The change of light was corresponded to what? Could you touch on that real quick?
Well, we're out of time. Maybe
okay.
Come back.
We'll catch him on the next one. Yep, no problem. No worries. Stellar, and then the other parallax. Okay. All right. Next round, sir.
All right.
How many topics are there?
3.
Three. 2 more.
Okay, so you got Alan going first now, right?
Yep.
Okay, Alan, I'll start your 10 minutes whenever you start.
All right. I'm going to grab a drink real quick. In his 1905 paper on the electrodynamics of moving bodies, Albert Einstein proposed that special relativity can be used to describe circular motion in a closed polygonal circuit, provided that the principles of his linear derivation remain valid in an inertial frame. In essence, if the angular rotation remains uniform, special relativity can offer a valid solution in alignment with its fundamental postulates of Lorentz symmetry and an invariance in the speed of light. Now to be covered, the relativistic explanation for the following experiments involving a uniformly rotating platform. For the Sagnac effect of 1913, which is attributed explicitly to angular rotation, it is stated that it's measuring measuring motion with respect to the fixed stars. Paul Lavou's explanation was to use the equivalence principle through general relativity and produce a tensor to calculate the gravitational field that a rotating device would produce with its energy, and that generates little pockets of length contraction and time dilation. So that's how they came up with the general relativistic effect with Paul Lavou. So some relativists will also make the concession that special relativity does not apply to the Sagnac device, as it is a non-inertial frame, though it is in uniform motion, as Einstein said would be able to be, which would make it applicable. For Michelson-Guerra-Pearson, which is attributed explicitly to a rotation that states that it's rotating, or that it's measuring a rotation with respect to Earth's axis of rotation. So it's following sidereal time. So it is stated in the 1925 paper that the effects were derived from a stationary ether theory. But we're also in agreement with relativity theory, though the Earth is said to be a non-inertial frame as well, despite the uniform rotational speed. So no relativistic derivations were shown in their paper. However, the relativistic coordinate system would have followed Paul Lavou's work, placing an observer at the North Pole where the axis can be assumed to be stationary, non-rotating, where they can derive their effects using a preferred reference frame, which will be touched upon later. Moving on to an extension of series of experiments regarding the Sagnac effect. In 1942, Dufour and Prunet reproduced the Sagnac effect of 1913 in its traditional configuration, where all the instruments are located on the non-inertial reference frame, i.e. the rotating platform, which we've found through Einstein's initial paper that it turns out it is an inertial frame. So anyway, also, they conducted experiments using a modified configuration to test the speed of light in an inertial frame, where special relativity would have to apply regardless of the relativist's opinion. Inertial frames adhere to Lorentz symmetry according to special relativity as per its first postulates, which is explicitly valid in any inertial frame. I will now detail the modified Sagnac experiments and their results. Experiment 1, using the traditional Sagnac effect, or using the traditional Sagnac configuration where all the experiments are located on the device. A fringe displacement was measured of 0.082, showing a first order dependence on rotation of 1 turn per second. Experiment number 2, to determine whether the motion of the source of light is responsible for the Sagnac effect, the light source was fixed to the lab with respect to the rotating platform and recorder. A distance in fringes was produced of 0.088, which corresponds to the angular rotation of the platform of 1 turn per second. The results are completely comparable to the traditional Sagnac setup. Configuration number 3, under entirely new conditions, in this new configuration, which the photographic recorder and the source remain fixed to the laboratory while a beam is reflected to a stationary platform with an independently rotating platform under it that's connected by angled mirrors so that the path of light can connect between the two independent platforms. So by taking clockwise and counterclockwise measurements before and after the readings and the mirror changes were done to average out, Dufour and Prunet found that the inertial motion of the rotating platform of 1 turn per second produces a fringe shift displacement of 0.019 between fringes, another first order dependence of angular rotation, this time transferred to an inertial frame. This experimental results is a huge contradiction to special relativity, as an inertial observer should always see no variance in C, especially if the platform isn't connected to them at all. That's rotating. Let's see. The frame is determined by the location of the recorder. In experiment 3, where the recorder is fixed to the lab frame, the fringe is obviously due to the angular rotation of the platform of 1 turn per second, since the fringe shares a first order dependence of that rotational speed. In accordance with relativity theory, experiment number 3's configuration makes the setup an inertial frame. Here we have a rare chance to test special relativity's postulates with a meaningful way that forces the relativist's hand to back up the claim that all inertial frames are equally valid. If special relativity selects the center of the rotating platform to derive the fringes, the theory is in agreement. However, testing Lorentz symmetry testing Lorentz symmetry of the frame reveals placing an observer on the location of the traditional platform, i.e. the rotating platform, relativity cannot derive the fringe displacement. Dufour and Pruner provide a calculative result for the relativist theoretical prediction. This configuration where the observer is on the rotating platform. Classical prediction says that the fringes will be displaced by 0.053, and relativity theory predicts that it will be displaced by 0.005 fringes, an amount approximately 10 times smaller than the actual amount shown from the observer's location with a proportion, in proportion to the area of the device where it was located. Let's see. It is shown here that relativity's first postulate is false. The center location is mandatory and not arbitrary, as Paul Lavou suggested in a direct response to this experiment. No fringe displacement that corresponds with an orbital velocity of 30 kilometers a second has ever been measured. Only a fringe displacement of only a fringe matching sidereal and sidereal time fluctuating relative to the latitude has ever been measured. If there is no orbital velocity, if there there's no orbital velocity in the fringe, and only a fringe with a first order dependence on sidereal rotation, then the logical conclusion is that the Earth is stationary with respect to an ether wind that translates motion from the sky, as was shown conceptually in the Dufour and Pruner experiment. This false, so let's see. The Dufour and Pruner experiment is proof of concept that the translation of motion between two objects affects the electromagnetic wave propagation. Segnek was correct in his original hypothesis about how he thought the ether worked, and that he falsified special relativity. A uniformly rotating platform generates its own etheric whirlpool within the greater whirlpool, as noted by Segnek in his 1913 paper. Question 2 for my opponent. Preface. Einstein explicitly details that his equations hold true in an inertial frame as long as their motion was also inertial. In Dufour and Prunet's 1942 experiment, configuration number 3 specifically of the modified Segnek system, system is an inertial frame by all means. The observer is fixed to the laboratory and is at rest with respect to the rotating platform. This is proof of concept that electromagnetic propagation is affected by a translation of motion between two frames. Michelson, Gale, Pearson measured a variance in speed that matches sidereal time relative to the latitude. Question number 2. Without a fringe corresponding to a first order dependence of a velocity of 30 kilometers a second, how do you know the Earth isn't stationary with respect to a translational motion of the sky? Relatively speaking, it should be identical minus the 30 kilometers a second velocity reading.
Okay. So again, it seemed like there was some suggestion that a circular interferometer should be able to measure linear velocity. Maybe I was picking that up wrong, but that's what it seemed to me, is that there was some suggestion of that. Again, within relativity, it's not expected that a circular interferometer should pick up linear velocity. But the constant speed of light does predict a shift when a circular interferometer is rotating, because the path length is increased in one direction during rotation and reduced in the other. So I don't see, when you're asking about the translational motion from the sky, how that has any connection to this, because that's not within relativity. But as previously referenced, a model needs to incorporate all observations. And so those 4 things that we talked about, maybe we will be talking about them again shortly, need to be, amongst other things, incorporated into the actual model and understood within it. So, and not just in a, we'll get into it. All right. So there you go. There's my answer to your question. All right. So, on circular interferometry, my time to start here, right, Jaron?
Yes.
Yeah.
You just and how much do you get? Yes.
10 minutes.
Or 10 minutes. Yep.
Yeah. So, again, circular interferometers aren't expected to pick up linear motion. They pick up rotation. That's all that they're expected to do. Again, the way it works, while the light is moving around the device, and during that time the device is rotating, the light, unlike our regular understanding of things, the light only has a fixed speed. So when it's moving forward in one direction, the light doesn't increase speed, and going the other direction, the light doesn't decrease speed. It goes the same speed while the thing is in motion. So while the light is in flight, one direction, it increases the length of the path, and the other direction that it goes, it decreases the length of the path. And so when the light is rejoined, there is a disconnect, a discrepancy in how long the light was in flight. And when you rejoin them, there's those fringes. So an interferometer, like a fiber optic interferometer, is just sitting on the surface of the Earth. So there's no ether to spin around with it when it's rotating. like on the Pernod table that you were talking about. Yet it still registers a rotation. That rotation is one direction north of the equator, other direction south of the equator. And if that device is actually sitting orthogonal, if the loop is sitting orthogonal to the upward vector, it registers nothing on the equator. This matches Earth rotating once a day, and is in line with relativity. So the I don't know, the things that you brought up, I don't quite see how they relate to this. I don't have a whole lot more on this. I think maybe it'd be better if we were to skip to the open discussion, because that's about all I have on the topic.
Okay, cool. So you said that the path of the
Let's
rotation
give
of the
Jaron
device.
a chance to catch up with this.
Oh, apologize.
I'm here.
You want to reset then?
Sure. So you guys just gonna do the 10-minute,
I do have a question for you. So
but you're supposed to at the end of that 10 minutes, right? So
yeah,
go ahead.
so I'm jumping to the end of the 10 minutes there. Okay. So as I said, a circular interferometer is orthogonal to the vertical, and at rest in relation to the ground measures a fringe shift proportional to the latitude, increasing farther from the equator, and 0 at the equator. And of course, it's opposite directions, north and south. What is the geometry and movement of the hypothesized ether to cause this magnitude and direction fringe shift?
All right, ready?
Yes.
Yep. You got a minute and a half.
All right. So the claim proposed here is that the orientation of a single axis gyroscope reflects the shape of the Earth, meaning that the z-axis has to be corrected by 45 degrees at the 45 latitude, for example, to be parallel with Earth's axis of rotation to get the full amount of the fringe reading, right? So if you were to go to the equator and make that further correction, you would get no reading as the relativists say. However, I'm going to need a citation for that, because I've never found anyone doing seismic experiments on the equator or even lower than the 45th latitude, really, with a single axis gyro. So here we go. So here's some instances that I did find. So here's a YouTuber named Doug Marmot. Here's his channel link and all that. Here's his device orientated 45 degrees. Here's his location in Toronto. He's about 45 latitude. So he makes a 45-degree correction, aligning it to Polaris. Now, the topic of this discussion isn't flat or globe, but I'll go ahead and give the rendition here. So on a flat Earth, you would be aligning your device to the axis of the sky to get the best fringe reading. And, that's a planar correction angle to Polaris would be the best way to do it. So on a globe, literally same thing. So as the observed data show so far, we've only seen one instance of a correction angle on a single axis gyro that matches the glob, and it also matches a plane, planar Earth. So here we have the Ginger gyroscopes. These are two laboratories that have a single axis gyro with a 45-degree correction angle located in their respective latitudes, which is also at the 45th degree, or right around that 45th, so indistinguishable from globe or plane. Here's the second observation place. This one's in Germany. The first one was in Italy. Sorry about that. So then here we have, for the geometric properties of the ether as follows: a vortex extending from the north. A vortex extending from the North Pole, extending out to the heavens outward from the vortex in an all-encompassing uniform motion, rotating east to west, facilitated by the east to west sidereal rotation. Here's a quote from Sagneck describing the dimensions of the ether as he measured them with his device in 1913. Quote, "The observation of the optical effect of such is of an ether wind relative to a stationary ether will constitute a proof that of the ether's existence, just as the observation of an ether of the wind relative to the atmosphere on the speed of sound in a moving system would constitute. Everything else being of equal a proof of existence of a stationary atmosphere enveloping a system." End quote. George Sagneck, 1913. Within that ether vortex is a body of motion that generates its own ether vortex proportional to its velocity. Right. So here's a potential overview of what it would look like conceptually. Don't pay any attention to the direction of all that, or, of the lines. It's fine. I didn't make the model. This is made by Patricia Holiday. So here we have an.
I'm just, I don't know if
Yeah.
Okay. I'm sorry.
We can jump to the 10-minute.
Am I good, Tune? I got like 2 more slides,
Sure,
and I
sure.
could wrap this point up because this was a good question, and I wanted to answer it fully.
And I want
Thank
to
you.
ask a question on that slide probably in a minute.
Awesome.
Yeah.
Awesome. Okay. So here we have some infinity symbols. This just marks the analemma. So on a flat Earth, what Miller would have been measuring is the fluctuation speed to maintain 15 degrees per hour. So that fluctuation would be what Miller measured as the sun goes into the southern hemi, where it has to, maintain its speed so that an observer in the northern hemi will still see it going 15 degrees per hour, right? So that's what Miller measured. That produces the analemma effect. And here we have the sun's path over a flat Earth. So just kind of recapping that overall. And then, of course, the cosmic microwave background is aligned with the sun's ecliptic as well. If the Earth isn't tilted at a 23-degree axis or whatever and all that, we're stationary, then it would default to the sun's ecliptic, because therefore the cosmic microwave background would be aligned to the sun's ecliptic. So the inertial spin, or I'm sorry, the motion of the Earth, of the universe, would be translated down to us in the form of an ether wind that causes a variance in the propagation of light. Here's the analemma again, in regards to that speed discrepancy that Miller was measuring. And here we have missing single axis gyro corrections. Have you seen any single axis gyro corrections or readings featuring a single axis gyro located at the equator and or southern hemi? If you have any information regarding the whereabouts of such readings or correction angles regarding a single axis gyro located at the southern hemi or equator, please contact me at allenspaceaudits@gmail.com.
All right. To the 10-minute here.
Okay.
Yes.
And do you guys, just real quick, I wanted to know, do you hear the bell when it goes off? Do you hear this?
No.
So just the audience hearing that. Okay. Now I'll fix that for next time.
Yeah, sorry about that. Thank you for letting me finish that, McTune.
Yep.
Or MC2. Sorry.
So in a second, I want you to get that other slide up, but the crap, what was that last point you were saying there?
If I no readings at the equator or at the or lower than the 45th really that I could find.
Yeah, well, we can do better than that. Airplanes have 3-axis gyroscopes, and they use
single axis thing, bro.
They usually have a total of 9 single axis gyroscopes in them, 3 sets of 3, and so they use the combined measurements of all 3 axes together to measure the rotation of the plane over a course of between 5 and 10 minutes while the plane is getting its location, and it determines its latitude. And this works both north and south of the equator. So it uses the actual gyroscope in there to get its axis. So any airplane that has a what's in
Can I respond?
IRS is they're typically called. So yeah, go ahead.
Inertial navigation system.
Yep.
Yeah. So if you look at the manual for the inertial navigation system, the idea that it just like magically detects where it's at based on some sort of rotation isn't true. You have to calibrate it first, and there's an explicit calibration process for that. So there's a couple of variations to it. So for the first iteration of it, you have the device stationary for 48 hours. While it receives GPS signals, whatever you want to make of that, and also you input your own coordinates on the map, latitude, longitude, and all that. You import it. It references it after 72 hours of turning on and off and taking readings. It will then compare all that data to what's called the Kalman data set. Now, the Kalman data set is something that we don't have access to. It's in the inertial navigation system. What that data set does is it compares all the readings relative to the latitude, and it makes decisions based on the readings that it's getting. Does it match? Is it correct? Blah, 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 right? So through its calibration process and statistical analyzation of the readings, it will eliminate, like error readings and all that kind of stuff, and produce, an accurate way to represent where you're at on the coordinate system after your location has been firmly established from multiple reference points on the system. And then so in regards to that system detecting things, that's cool, man. That's going to give an output reading. That's not really what we're interested in, because when an inertial navigation system goes to the 86 latitude north or south, it switches into a different polar navigation mode, or I forget what the other one is for the south, but it switches into a different navigational mode where it has an entirely different map set, etc. So the idea that readings couldn't be fudged on the end of it based on where it's at to switch coordinate systems to reflect what you would expect to see for the outputs, there's not a lot to make of that. What was really significant, though, was the single axis gyro readings, which would further help actually produce meaningful results for like someone like you and me who don't have $20,000, $30,000 for an inertial navigation system. It's like these kind of readings would help map that out and what's the word I'm looking for? Kind of validate heliocentric mythology of the claims of the readings at the equator and in the southern hemisphere specifically.
Okay, so obviously you have to calibrate an instrument. That doesn't make it read it wrong, and it's not. You don't need to go to every airport south of the equator and calibrate it at those locations. It uses it when it's there. It uses the measurements within the device to determine its latitude.
Right after it's already been established on the coordinate system. Yeah, like
the gyroscopes don't have any notation of a coordinate system. The airplane does, right? The whole computer system of the airplane does, but the gyroscopes don't. They don't know where they are. They only know their latitude when they're
that data gets inputted. Yeah, that data gets inputted by when you boot it up for the first time, and then it cross references that with other things that you can select like GPS and other references.
But there's no GPS in a fiber optic gyroscope.
Listen, my dude, the readings though, like the whole system, the inertial navigation system itself is a baby supercomputer. It's going to take all these readings and use the Kalman data set to compare it and output the information based on the coordinate systems that are given it to it, which are globular, of course, right? So it's going to spit out information that produces that. So the main point of your contention was that the alignment that we can verify of a single axis gyroscope, right? Like that's what we could have that would help bring add substance to your claim or help map out how the ether works in the southern latitudes. Because I think at the equator it would still give a reading, and on a globe obviously it would have to be symmetrical. So as you get away from the equator on the southern, you would start getting reading symmetrical to what it would be in the north, right? I think it just keeps getting higher. But we don't have single axis gyro. There's no single axis gyro readings to compare.
Well, to
model it out.
To falsify science, it's on the claimant, right? Single axis gyroscopes are not actually that expensive. The same manufacturer, I believe, as the one that Bob used, has a single axis gyroscope that's quite a bit less expensive than the three axis gyroscope he used. I think
this guy made his
couple $100 for an actual from the same company that Bob Nodell used. So if that if you want to falsify it, but
well, you guys are the one claiming that you guys are the one claiming that those are the correction angles. I just haven't seen it. You guys always talk about it. I just haven't seen it. So wouldn't it be on you though to show that those correction angles are real?
I'll just go back to referencing
rather than abstract mathematics, right?
Yeah, I'll just reference the one that the airplane uses. Right?
Okay, if you want to take multi-axis gyros or multi-axis gyro readings that are averaged out over a data set that you can't confirm or look at, that's fine. Totally good. We can move on.
All right. Bring up that page that you had a couple ago there.
Paper and page. Was it on this or was it on my presentation from earlier? I think
it was second to last or third to last that you had up.
Hang on a second. Was it on this or was it on when I was doing my speech?
Not that one.
None of this. Okay, 1 second. I got you. What would that have been? Circular interferometry. All right, here we go. Oh yeah, from the DeFore and Pruner.
That's not it either. It was the flat map with the toroid on it.
Oh shoot. Okay, 1 second. Flat toroid map. Yeah. Second. Sorry about that.
I stopped the clock for you anyway, so we'll start as soon as
Thanks, Jared.
Okay, thank you. Okay, there you
Good.
go.
There, that's the one. That's the one.
Mhm.
Okay, so now, I hope everybody's hungry because that's a nice looking donut. But so that one there. So like I said, and I'm gonna go with the what is understood is that the gyroscope perpendicular to the vertical will read 0 at the equator. So taking that, and if you dispute that, well, we can do that later. But that is the claim, that is the understanding. So can we just take that for this conversation? Is this particular toroid is showing the flat Earth? Is that the perimeter of the equator, or is the equator halfway between the pole and the perimeter?
Oh, it's halfway in the perimeter somewhere in there. This is just the conceptual thing.
Okay,
This
so
isn't-
so how would
and
that? Because that doesn't match where
How so?
there's nothing on the equator, no horizontal measurement on the equator.
I see. Where's the axis of rotation on the globe? Or how do they align it, right? They say that they align it to Polaris. They're making correction angles to Polaris, right? That's what they say.
No,
So
no,
yes,
not
yes.
to Polaris.
No, explicitly. Yeah. So
Polaris
yeah.
is half a degree off the center of rotation.
Okay. I'm talking about like vertical orientation, right? So like if you're on the globe and you have to be tilted away, you have to tilt the device at 45 to match the sky. You understand?
Yeah, I
That's
guess.
what they're- that's
Yeah,
what
if your margin of error is plus or minus half a degree, then yeah, you can point it at Polaris, or it's a little
Right.
harder in the southern hemisphere.
They pointed to the north, which is Earth's axis of rotation. Fair enough.
Sure, yeah.
Great. Okay. So with that, so on the globe, they say that you have to, horizontally, you curved away, blah, blah, blah. So you have to correct the z-axis by 45 degrees if you were at the 45th latitude, for example. On a plane or on a planar Earth, it would be the exact same thing if you were, let's see, let me pull this up real quick if you can just, conceptually see it. So if you were just away from this, right, the axis of rotation is facing the sky, is going up towards the sky, right? That's where the motion's coming from, as noted when Miller did his readings at altitude and got more, got a stronger reading. So when you're aligning the device with the sky, that's where you're getting the strongest readings. It matches a plane for the single axis gyro readings. Now, if you want to get into the multi-axis gyro stuff that we can't confirm and blah, 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 like that's fine. But for the single axis, I mean, the most available data in 2023 is 3 people all located in the same spot loosely, where it's indistinguishable from a plane based on the given corrections angles to align with Earth's axis of rotation.
Okay, but I don't know if I didn't quite get the answer to what how that toroid look would explain the measurement that's on the equator for a horizontal gyroscope.
Did you say you had a single axis gyro to show that data?
Are you gonna go with that, man?
Absolutely.
Fine. All right.
It's only $200. It would be the most profound proof of the globe ever. You know how schools do that experiment? Hold on a sec. Dude, hear me out.
You guys would all hand wave it just like everything else. Come on.
No, I mean, obviously we would incorporate it into our own theories, but hear me out. Like you're saying,
that doesn't sound very profound.
Hear me out, though. It would be a great experiment for schools and stuff to do. So like, how they do the sun shadow things on the solstices or whatever, and they plot out all the data. Are you familiar with that? So like there would be a similar thing where schools at different latitudes would have their data, and it would show like, oh look, these correction angles are based on the globe. Like the only readings and the only available stuff I could find in 2023 is 3 spots, all in the same location. It's insufficient at this point to continue that. For me, I mean, if you want to believe in it, it's totally cool, but I need to see some more. I need to see it now. You know what I'm saying? Especially knowing how the inertial navigation system works itself, right? So once you know all that, how it works, how it calibrates, and the common data set and all that, you're just like, okay, well, I'm gonna need something a little different, So.
All right.
Okay, you ready to move on from there? That's the end of the 10-minute section for the exchange, and then we're back to interlocutor A.
That's me. Interlocutor.
Whatever.
Interlocator.
It's okay.
Let's just say that I didn't know that word existed until yesterday. So
yeah, it's all good. All right, I'm ready.
Okay. You got 10 minutes. And what's the topic now?
Time dilation and length contraction.
Alrighty. Sounds great. Here we go. And begin when you want.
All right. I may share my screen here in a bit. I don't know.
Okay.
We'll see. All right. Anyway, special relativity makes specific claims about the speed of light for different observers, which affects the relative passage of time for these different observers, as well as the relative size of objects in frames of reference outside the observer's frame. Time dilation and length contraction are the names given to these related predictions. As an object's velocity relative to an observer approaches the speed of light, time passes slower relative to the observer and objects appear longer. In 1972, Haefel and Keating used 4 cesium clocks to test time dilation. They synchronized the 4 clocks, then flew 2 of them around the world, once eastward, once westward. From the actual flight paths of each trip, the theory predicts that the flying clocks, compared with reference clocks on the ground, should have lost 40 plus or minus 23 nanoseconds during the eastward trip, and should have gained 275 plus or minus 21 nanoseconds during the westward trip. What was observed? The flying clocks lost 59 plus or minus 10. Prediction was 40 plus or minus 23. During the eastward trip, and gained 273 plus or minus 7 compared to 275 plus or minus 21 during the westward trip, matching the prediction. This was repeated in 75 by Carol Alley and a team over Chesapeake Bay. A plane was flown in loops for 15 hours. Relativity predicts the clocks in the plane should lose 47.1 nanoseconds, and this matched the observations. There were other repetitions of this test too. I won't get into it this time. So another way to test time dilation and length contraction is by measuring muons in the atmosphere. Muons originate high in the atmosphere, and they have an average lifespan of 2.2 microseconds. This is empirically tested elsewhere. Since they travel at nearly the speed of light, relativity requires that a Lorentz factor is applied to the lifetime. In 1963, Davis Frisch and James Smith measured the number of muons. In their experiment, they called them mu mesons. That's what they were called at the time, but they're muons, we call them now. Measured it at Mount Washington, which is on the East Coast there, at 6,265 feet elevation, and in Cambridge, Massachusetts, at 10 feet above sea level. They used several tons of iron above the detector to restrict the speed of the mesons, or the mu mesons or muons, to between 0.9950 and 0.9954 of the speed of light. So a very narrow range. They measured 563 muons per hour on the top of the mountain and 408 per hour at 10 feet above sea level. This confirms the muons originate in the upper atmosphere, at least, because they had a lower number down low. When we apply non-relativistic analysis to the travel time for a 0.9952 of the speed of light, that's the average time of that little range, muon, it must take, for that 6,252 feet, it must take 6.4 microseconds for it to travel that. But the average lifetime of a muon is just 2.2 microseconds. That's an average. Based on the non-relativistic prediction for the 10-foot measurement is 27 muons per hour, not 400 something. The measurement was 412 muons per hour. The non-relativistic prediction does not match. The experimenters then calculated the Lorentz factor to be 8.4 plus or minus 2. The observed factor was 8.8 plus or minus 0.2. The prediction matches the observation. This particular measurement is in the PDF that's out there, including a video that they made in 1963. It's pretty good video. It's worth your time if you're interested in this topic. In 2018, Efren Koravabias, I don't know. I'm sorry, I got your name wrong. He measured muons at 100 feet, 4,200 feet, 6,200 feet, and 8,600 feet elevation. The non-relativistic prediction for the number of muons at lower elevations drops drastically, but the measured quantities do not drop this fast. The muon count matched the relativistic predictions in this experiment as well. So I will share. Give me a second to get.
Okay.
Yeah. All right. I'm going to share this here.
I'll pause your time real quick here.
There you go. No, I'm good. I got it.
You're back? Okay.
All right. So to go back to the first of the two muon measurements, we've got Mount Washington and at Cambridge there. Here's the table. Are you seeing that table?
Now we are.
Okay. My people aren't. You want to pause my timer for just a second again?
Yep.
Oh, you know what? I'm back.
Okay,
I was quick. Okay. There's the table. They did 6 different runs. That their average was 563 on the top of Mount Washington, 408 at the bottom. There is our Lorentz factor there. That they used to get the predicted factor of 8.4 plus or minus 2, and then the observed was 8.8 plus or minus 0.2. So right there within the prediction. Then to the other one where they measured it at 100 feet, 4,200, 6,200, 8,600. This is the prediction right here for the relativistic prediction. The reason why you see this is kind of a slight curve is because of length contraction, time dilation, right? The time for the muon ticks slower than it does for from our perspective, from our frame, than to the muon's frame. And so it extends its lifetime versus here is the non-relativistic where you have the steep elbow or knee on that curve where it just has 2.2 microseconds to live. And then it's an average, but it doesn't go that far out of the average. Here's the actual counts at the different elevations. I quoted them in feet. Science is done in metrics. So there you go, 32 meters, 66,000. And you can see as they increase up to 1,400, 1,800, 2,600, the counts increase, again confirming that muons come from the upper atmosphere. And the per second muon rate there is increasing with increasing elevation. And then here's the chart charting the relativistic prediction that's actually the measurement, and then that's just a line fit of the measurement there. That's what that line is. And then this is the bottom one, is the non-relativistic. You can see where it does not match. So all right, there's my graphic presentation. So that's it for my presentation. I'm going to jump right up to the question here. So preface, Haefel Keating flew clocks around the world. After the eastward trip, the moving clocks had lost 59 nanoseconds. After the westward trip, the moving clocks lost 273 nanoseconds. And then Carroll Alley and Company in 1975-76 put the cesium clocks on a plane and measured about 47 nanoseconds slower after 15 hours. Question is, what is the non-relativistic cause for this loss, and how are the magnitude of the effects predicted?
A minute and a half.
All right.
Yep.
The non-relativistic cause is electromagnetic retardation. All atomic clocks experience this. Further, an atomic clock in motion experiences the retardation, typically seemingly at random intervals and at varying magnitudes. This is noted by Louis Essen, the creator of the atomic clock. How would one go to calculate these effects? Well, this was done by Oleg D. Jefamenko in 1997 in his book titled Electromagnetic Retardation and the Theory of Relativity, where he goes into explicit detail showing all the calculations on how to do it just using the laws of electrodynamics and electromagnetics and classical mechanics, right? So he's velocity, movement, right? So, and then he has a separate paper, which is a little easier to digest, from 1996, titled Direct Calculations of Time Dilation Using the Same Effects. Okay. So basically just an electric field with varying magnetic flux densities will cause the clock to go out of sync, at varying degrees.
But why on the airplanes are they seeing this?
It happens when they're stationary as well. The corrects are corrected in the are corrected in the clocks automatically. So when it gets out of sync, what it does is the two magnetic fields in there that are keeping the cesium atom in its excited state of 12 million oscillations a second, or 12 billion oscillations a second. It just displaces those ones, and a new one will step in, and then they'll just send in radio wave energy at it to keep it at from decaying from its oscillation rate, and they just keep it in that excited state. It happens, to varying degrees. There's no explanation for it, or any predictive explanation for it anyway. It's just something that they have to deal with.
But that's not what they actually found in the, for example, the 1976 experiment.
Okay, well, I was just responding to your question. If I can get into my presentation, I can answer all your questions about the clock with that, but it's tied up in my full presentation.
Okay.
So
all right, that's fine.
Yeah. I was sorry. I was just on that specific question in regards to that. Yeah, because you were asking for like a calculated, like how would you do it without that? So I was just showing you that Jeff Fomenko has done it. Totally doable. Just not a lot of people do it because everyone is a relativist these days, as they say, right? So if we're good on time, am I good to start my presentation?
Right. So you go 10 minutes. Yes.
Awesome. All right, so here we go. Okay. Sorry. Time dilation and length contraction on Einstein's clock synchronization. Einstein, in his 1923 Principles of Relativity, defines the relativistic effect of time dilation experienced by a moving clock that's following a continuously curved path as being equivalent to a clock that's traveling along a linear path, as in earlier we discussed the reference frames being equal as long as the motion is inertial. So when comparing a moving clock to a stationary clock that share the same point of origin, after the moving clock completes its circuit, the two clocks will be out of sync by an amount proportional to 1/2 times velocity squared, or v squared over c squared times t, where v is the constant velocity of the moving clock, c is the speed of light, t is the total time elapsed according to the stationary clock. This alteration of time in reality does not manifest. If a rotating disk produces length contraction and time dilation, then the area of the disk must be corrected for. However, no such corrections are necessary when used to derive the prediction of how much a wavelength will change for an inertial or non-inertial observer. For length contraction and time dilation to be physically manifest for a SAGNEC device, for example, it would have to be configured for its rotationary state as its lab state would be or would not be invariant, because it's the apparatus is changing, the distance the light's traveling and all that is changing. This was experimentally shown to be not be true. The apparatus is as configured as noted by the math that's used to derive the effects without accounting for any of that stuff. So a stationary configuration of the apparatus would not be invariant with the went over that. A stationary or moving light source has no effect on the wavelength. A stationary or moving observer records the same invariance in C that has a first order dependence on the angular rotation of the device, which was experimentally confirmed by Dufour and Prunet. Note that an atomic clock synchronization only accounts for the SAGNEC effect. Quote from Marmont, 2000, the GPS and the constant speed of light. So he goes over the equation used for how they synchronize these clocks, as we were talking about earlier. They don't use a relativistic equation. It's similar to the how Wang's equation was written out from the earlier slides. Another attempt to measure the specific effects of time dilation was the around the world atomic clocks experiment conducted by Heffel and Keating. Their experimental results, their experiments using a cesium clock were to measure time dilation. The results of the experiment using a cesium clock to measure clock synchronization at altitude, testing the effects of how different gravitational potentials and relative motion through a gravitational field as they circumnavigated the equator would affect clock synchronization as they're going east to west and then west to east. Heffel and Keating published their findings in the 1971 paper titled Performance of performance and results of a portable clock in an aircraft. The results published do not give a relativistic agreement for the prediction of clocks for all clocks uniformly gaining or losing time, respectively. Did not give an agreement with relativistic effects all of the predictions of the clocks uniformly gaining or losing time in their east or westward journeys. Originally, their published work show that the flight travelings on the east side, 2 of the 4 clocks gave a reading opposite of the relativistic prediction, meaning they lost time when they were supposed to gain it, and then the same thing happened on the opposite trip with a different set of clocks where they gained time when they were supposed to lose it. In lieu of this great discrepancy that occurred while the clocks were in motion, Heffel and Keating proceeded to carry on with their results. Whenever a clock displayed a sudden change and shift relative to the other 3, this effect was ignored. Had this effect happened once or twice, the experiment would still have some semblance of credibility. However, this happened 14 times of sudden clock changes where those changes were ignored, and then suddenly ignored, and seven of the fringes were being tied to the same clock. Republishing their corrected data in 1972 under the paper titled "Around the World Atomic Clocks Predicted Relativistic Time Games," the aforementioned selective time corrections, in addition with supplemental corrections of the newly published data, reflects the changes showing relativistic predictions. So the original readings were negative 66 nanoseconds going east, and the corrected values showed negative 60 or negative 59 nanoseconds. And then going eastward, the original reading was plus 205 nanoseconds, and the corrected value was plus 273 nanoseconds. And they didn't even publish the supplement corrections and stuff that they did to make it all in alignment. They just did that and then showed their results and were like, hey, it all matches. It should be noted that all atomic clocks desynchronize at varying rates, stationary or in motion. This experiment testifies to that. And in fact, the entire functionality of the atomic clock utilizes 2 counter-rotating magnetic fields and microwaves to maintain an expected oscillation rate for the cesium. All magnetic waves are subject to electromagnetic retardation, and none of the retardation requires so-called relativistic effects. And then on muon decay, the claim of muons is that they are created by cosmic rays at an elevation of 50,000 feet. This assumption is based on the ground level muons that are detected, and they shouldn't be there according to their half-life. But the basis for the claim is that their genesis starts at 50,000 feet, and then through relativistic means they can extrapolate length contraction and time dilation to explain why there's more muons on the surface of the ground. But that doesn't explain. If the muons are created at 50,000 feet, they could be created on the surface. There's no relation that the muons that they measured on the surface are the same ones that are created, that have to have relativistic effects to survive their so-called trip to Earth that's length contracted and time dilated. So in the 50,000 kilometer or 50,000 feet where they're born in the atmosphere, so to speak, comes from the upper limit of the relativistic correction based on their time half-life and their speed. So let's see, within the relativistic paradigm of using length contraction and time dilation, the maximum distance relativity can achieve for the 2.2 microsecond half-life is 50,000 feet. The verification rests on the correctness of the genesis of the muon in the atmosphere, which gives the relativists their conditions to calculate. So question preface. The Einsteinian clock paradox of clock A completing a circuit, returning to a stationary clock B, only to find that in the instance that it is returning, that both clocks are younger than each other, has never been physically manifested in atomic clocks, and it cannot be said on whether a muon is created at sea level or at altitude. Preface 3, question. I worded that backwards. Question. How can clock desynchronization be contributed to relativistic effects when no relativistic paradoxes to accompany them manifest in reality? Likewise, how can the detection of a muon be attributed to relativistic effects when no one has measured a rod in motion become shortened by length contraction? All right, and then I rest my case, Your Honor.
Okay. I don't know what you're talking about when you say that they've not physically manifested in atomic clocks. I cited Carol Alley's measurement as well. You talked about hateful Keating stuff. None of what you talked about was in their 1972 publication, so I don't quite know where you're getting the stuff from. Certainly would need to look at it.
Yeah, my bad. Did I not? I'll check it later. My bad. It's from their 1971 before they republished it with their corrections. Yeah,
Okay.
I'll send you all the stuff on
Well,
it.
I see the 1971 thing in the list there, but
yeah.
the 1970. Why would I don't know why that would be preferred over the 1972 publication. Wouldn't the one that they actually sent off to the journals be the one that they want to reference that you'd look at?
No, their original findings were completely unsupported. They had to make a ton of corrections that they didn't publish or tell anyone how they did it. Some guy in another paper that I didn't bother referencing, but I have a picture of it or in the slides. But anyway, in this guy's paper, he reverse engineered the effects, just guessing what it would have to take for the corrections, just making up his own arbitrary stuff and derive the effects, for fun. So whatever they did on their end, they didn't even tell anyone. It's very dubious and weird to say the least. And all that proves is that the atomic clocks go out of sync at varying rates, which is what they do, as noted by Louis Essen, the guy who made them.
Okay. Well, then, Jaron, I'm going to share.
Okay.
Here. There's that.
You're good.
Okay. So here is from the 1975 and 76 from Carol Alley. There on the right, this chart. This is the deviation in the clock.
Mm-hmm.
On the left, this is before the flight. This line going up to the right is the during the flight deviation in the clock, and then there's the post-flight deviations in the clock. And you can see before and after the flight, they are not deviating randomly in significant magnitude. During the flight, they are deviating significantly in magnitude, and then when they stop flying, they stop deviating again. So just saying they randomly deviate doesn't make sense when you look at the correlation between the deviations happened while they were in flight and before and after they were in flight. The deviations they had, certainly there are. Nothing in meat space is perfect, but the deviations had a very small magnitude and weren't just jumping by large amounts.
Okay.
Before and after.
That respond?
Yeah.
Yeah.
You guys are in open communication, right?
Yeah.
You should be now. Okay.
Yeah.
So relativity theory, based off of its mathematical, how its structure works, it's a kinematic theory. So it can be used to analyze things and make predictions and stuff. It doesn't mean it's going to be right 100% of the time. The fact that it turned out in this one instance for the relativist is great, but the fact is that how they synchronize atomic clocks and GPS when they're actually using them and not doing an experiment for a limited time to reify relativity theory, the way that they actually do it is they just account for the Sagnac effect using a similar equation to what was shown earlier with no relativistic effect.
This isn't GPS and this isn't taking into account Sagnac effect.
I understand that, but relativity theory is a kinematic theory. It does make predictions that are valid, every now and then, but it doesn't describe the physical mechanism of any meaningfulness, right? So length contraction and time dilation are abstract concepts applied to the kinematic relationship that they're describing, right? So when you have a prediction that matches it, you're like, oh, cool, no way, it works out. When you try and plot that dynamically and see how it works, not even close. It never works. In fact, they can't do it. I know I've got a couple of papers of people that have tried and they can't do it. So
when they try to plot this time dilation,
when they try
from
to make dynamic
1975, 1976, Carol Alley, when they try to make dynamic predictions based off of kinematic solutions from relativity in regards to clock synchronization, length contraction, stuff like that, it doesn't work out because the effects are not actually real, and it doesn't. It makes predictions sometimes, like in this isolated incident. Okay, so you're saying this prediction is and the matching with reality is wrong then?
No, I'm saying that relativity theory occasionally does match up with that. It wouldn't have any useful as an analytical kinematic framework if it didn't. That's all it is.
Okay.
People are confused and think that the hypothetical reference frames are real reference frames that verify a reality in which the kinematic coordinate system of length contraction and time dilation as the mechanism which is never physically manifest to describe the theory.
Except it's physically manifest. I mean, we've got the correlation here where the theory makes a prediction, we test it in reality, and it matches.
Indeed.
Right? So we have this confirmation here. It's one of many.
Yeah.
Right? Okay. I'll stop sharing that. You said you didn't think that muons could be created in the upper atmosphere, even though the two different.
Not what I said.
Okay, go then clarify.
Oh, I said that they could be created at the or closer to the surface or anywhere really, and that there's no evidence that the muon created at the altitude that they say needed for relativistic effects to take effect. There's no, you can't verify that that's the same muon, so it's just kind of a calculative assumption and all that. So
yeah, well, so neither of the two things that I cited specifically relied on the elevation of the muons being at any particular elevation, just that there's a variation from at different elevations, and the time that a muon lives, 2.2 microseconds on average, versus the time that it must take to travel from that elevation down to the ground is too far.
Right. Exactly.
Takes longer than 2.2 microseconds. So there's no way to have the numbers of muons at those different elevations without something other than Newtonian mechanics.
What's your evidence that a muon can't be created at a different location than what is presented at the upper limit of the relativistic prediction based on the half-life and speed that the muon travels? It literally is explicitly tied to that genesis location, because if it's not, then it's not then it wouldn't be a proportional transformation. So it's literally hard capped by that. It's very reification in that regard. It is what it is. I see why you think it's a good proof and whatnot, but when you look at it, for what it is based on its decay life and its speed, they've just kind of reified the position of its genesis to say
again,
the relativistic.
Neither of the things I cited specifically care about the actual genesis. They don't include that elevation in any of their application. They just use the differences in elevations of the two locations that they did in the 63 one and in the 2018 of the 4 different locations. None of it matters how high it originates. It's just between those specific levels.
Right. And it does matter because the amount predicted, or that they see, how much they see up here is based on it being created up here. So it's explicitly tied to it. And especially because, time and distance have to contract proportionally for it to all work out. So the upper limit is hard capped by that prediction. It's very reification in that regard.
Okay. So. It matches again. We have an example where it matches relativity. It does not match any known Newtonian or classic mechanics. Why is there a specific magnitude of muons measured at 8,600 feet and a lower number at those different elevations?
So the discrepancy there could be due to anything. There's nothing on your side that other than starting the genesis point where it would be contracted proportionally.
Yeah. I'm asking for your explanation.
Based on its speed and mass. That is the explanation. We've been kind of going in a circle in regards to this topic for the last couple of minutes. And I think either, I mean, do we move on? We're doing good. We got 3 minutes. We could chop up something else.
All right. I ain't get no satisfaction.
Yeah, well, same. But I don't want to keep it going because I feel like it's kind of doing the same thing here. So let's what else did you have on in regards
how about Romer?
Romer, what was that, the speed of light, Jupiter and all that?
Yeah.
So just off the top of my head, I saw a paper by a guy named Stephen Griff, who is he's an ether guy, and he does his own calculations using his own ether framework model and select transformations to facilitate all the same things with an ether framework and the variance of the speed of light. That's what you're talking about, right? The detection of the speed of light, so to speak. That's what Romer did.
Well,
Using Jupiter's moons.
some
that his
people,
contribution?
some people attribute Romer to being the first to measure the speed of light. But the thing that I'm mostly concerned about is that Io, Jupiter's moon Io, gets eclipsed by the Jupiter's shadow. And some parts of the year you can see it become eclipsed, and some parts of the year you can see it exit the eclipsing. And they had very precise measurements of when that should happen. And Romer discovered that there was a 10 to 11, somewhere between 10 and 12 minute difference from when we are at one part of the year to when we're at a different part of the year. And of course, that's the difference of the diameter of Earth's orbit of the sun.
I'm sorry, could you restate that? Or what was the end part of it? Sorry, I zoned out at the last 10 seconds, man. I apologize.
Okay,
I didn't do it on purpose.
It's the discrepancy in the when the shadow or when the moon gets eclipsed, when we are closest to Jupiter versus when we're farthest from Jupiter in our orbit around the sun. And that diameter there, it's not exactly closest and exactly farthest because we can't see Jupiter through the sun.
Right.
It's between 10 and 12 minute difference from when we're close to Jupiter versus when we're far from Jupiter when the moon gets eclipsed.
Yeah, I'm not super familiar with that one. As far as I remember from Romer was that he closely predicted the speed of light based on that. Is that what you're getting at, or you
can output the speed of light from that, but he didn't have actual strong. At the time, they didn't have as good of distance measurements of the radius of the Earth's orbit, so it was more of a ratio.
This is okay, got you. Okay, yeah. So you could probably plot that against the sun, and it would show the same thing, similar to stellar parallax. Like that would be my default answer for that, but again, I have no basis for that. That's just assuming it based on how it works with literally everything else that you could model it. So I assume there would be some relationship with that, but again, no idea.
All right. Well, apologies to Romer for mispronouncing his name.
Yeah.
Romer will be okay. All right. Time up there. So let's move on here. What do we do now? If you've got your... That's it?
Yeah, that was it.
So you guys are going to ask questions after. So the questions were all asked inside there.
Yeah. So we used our big ones for something like the Romer, for example, where I wasn't familiar with it and didn't really have anything to contribute to it. We focused our big questions. We sent them ahead of time so we would have a jumping off point to get into the discussion, that was the big part of that, just to have it focused on that. So that was awesome. Thanks, team. That was great.
Yeah, I think it was a
very
good
very enjoyable.
We'd love to hear some people in chat or comments. Just let me know what you thought of their format. If you thought it was too long, the 10-minute sections, or if you think that that's enough time, or if they need more. What did you guys think? You think that's about right, Mike? You like that 10 minutes or?
I like enough time to explore a concept, and so somewhere between 5 and 10 minutes in a debate structure like this, right? It's not a lecture. You can't get it into that, right. But I think that's a good amount of time. Much less than that, and you just don't give a topic its due.
Yeah,
I would agree with you. So I thought you guys were great. What do we got next week? We have we're gonna have Jeffrey Daughtry against Dustin Nemos. Another is the Bible trustworthy, and is Jesus a real character? So that'll be next Tuesday at 6 p.m. Pacific. If you want to debate, you can go to jeranism.com/debate. There's the layout there, and then there's a form you can fill out, or you can just reach me on Telegram, which is probably the easiest, quickest way, t.me/jeranism. We're going to give these guys one more time. And, maybe one of them swayed you with their argument tonight, maybe not. If they did, and you thought that they were honest and they did a good job, please give them a follow. Go over to Space Audits, Alan's YouTube channel, give him a sub, and also MC Tune Live. Is that what it's called? His Tunes channel. So go give him a sub if you want to do that. And also support these guys. Support whoever it is that you want to continue seeing, because Otherwise, they might go away. So, guys, I'll let you guys give your final words. Do you have anything? Go ahead, Tune first if you have any final words.
Well, thank you, Jaron, again for hosting. I think this is a good venue to have a good exchange, rather than some of the other flat Earth debate channels around that don't ever allow debate. So I thank you for that. Alan, it's been good. I really enjoyed putting together this structure and working with you on the PDF that we distributed to everybody here. So thank you for that.
Yeah, it was a blast, man. It was a pleasant surprise to work with you behind the scenes. Like I'm gonna go ahead and spill a little beans, guys. McToon's a nice guy behind the scenes. So I'm sorry, MC Toon's a nice guy behind the scenes. Not that bad.
I would never say that.
But yeah, it was an awesome working through and getting that set up. I hope everyone in the audience, gets something out of it, and it was enjoyable for you guys to watch it as it was for us to work through it and present these highly complex subjects in a way that you could get maybe a little bit of digestible information out of it either way. So thanks for that, Jaron. Thanks for hosting, and
Yes.
Toon, thanks for accepting the challenge. It was awesome.
Yep. And if anybody's got any ideas, I'm open to ideas. This is still a work, it's in the works. It's not finalized yet. And in fact, we do have an intro, believe it or not. I just didn't have time to get it up today, but there's already the intro music is done. But anyway, for the layout, if there's maybe you have a suggestion or an idea, go ahead and submit that if you want in the comments. I'll check that out. But next week, I think you guys will enjoy it. Next week is the first time that everyone's going to go by my rules as far as the layout. So Dustin Nemos and Jeffrey Daughtry, and they're not going to be exchanging, so they will not know each other's claims or their questions ahead of time. They want to do it blind. So that'll be the first time I think that we've really seen that. I think everybody else exchanged first. So should be fun to check that one out. That's next Tuesday, 6 p.m. Pacific. All right, guys, for me, I will see you on Thursday at 6 p.m. for Speaker's Corner. Come on by. You can go to tinyurl.com/cornerism, and that's how you join the show if you want to come on and say something. And then also on the screen is I made a little tiny URL, tinyurl.com/tune PDF. If you go there, you can get the layout that they used tonight, and then also the PDF that Tune made that has all the links to the various references, the different papers and everything else. So thank you for doing that, Tune. Appreciate it. All right, guys, I have no outro music yet, so we're just going to say goodbye.
All right. Thanks, guys.
Peace.
Till next time, guys, do your own research. When you do, you'll never again believe the bullshit you've been taught. Till next time, this has been Jeranism. Debatism. Peace. All right. Thanks, guys. It was fun. I think I learned some stuff.
So I'm gonna keep going on my channel, Jaron and
have
Alan.
fun.
Thanks a lot.
Yeah.
We'll
Yeah,
catch
peace,
you later.
man.
See you later.
All right. Well, people, thanks for tuning in, if you know what I mean. That was tell you, I put a lot into that. You probably got the idea. Alan's no slacker like most flurfs are. He definitely wasn't just parroting memes. He read these things. He tries to understand them. So I'm going to read some super chats. If anybody wants to come on and has some feedback for me, thoughts on the topic, anything in particular, message me on either Facebook or Discord, and you can join in a couple minutes here. Let me see here. So does he Kango 44? I think I read this before, but it's great. Before the relativity talk, does he want to cover something a bit simpler, like how the sun sets? Tim Tully says 11th law, gotta interrupt a flurf. Now that didn't happen. Gotta be fair. Okay, Patrick Butler said linear what? Flat Earth already lost? It's tough coming from a pre-losing situation if you're supporting Flat Earth. Naricul said evening, MC Toon and chat. Mr. E-Man says, accept my compensation for the lack of evidence and measurements of flatness. Thank you, Mr. E-Man, for the 10 Australian. yes, there was a lack of evidence and measurements of flatness. He did have some first law there, definitely. He really likes the Dayton Miller stuff, and he also likes Hector. I forgot. He's from Columbia. He really likes Hector, but Hector says everything that Dayton Miller did is crap, and because it didn't measure things appropriately. You can't have it both ways anyway, but both of them determined the within there, if you accept their work, they both measured the velocity of the solar system moving through the galaxy. They came up with quite different answers to it, which are it don't work with each other. And when I asked him if he had done any work, to apply the geometry to flat Earth, he did not. That would require a flat Earth model. There is no flat Earth model. He likes the AE map. That doesn't work. It never works. No part of it ever works. If he were ever you could potentially map all of the motion of the whatever Dayton Miller supposedly measured. You could map that, but the problem is, Dayton Miller did a lot of his stuff in either Cleveland or Mount Wilson. All of his calculations determine that the direction of the solar system is in the south celestial sphere, which would be through the flat Earth, right? So the ether is coming up through the flat Earth at 400 kilometers per second. That's what you'd have to conclude. That doesn't work too well for flat Earth. I've liked reading through this paper. I'm like, well, how would this work for flat Earth? It would be a disaster, an absolute nightmare. And he specifically says that it's headed towards a spot in the south celestial hemisphere. Right. Well, if you take the celestial sphere and the globe and you bring them both, project both of them onto an AE map, right? The Earth gets mushed up into the AE map, the Gleason map as they are, and then all of the points of the celestial sphere have to get brought up with it into what? A celestial plane, a celestial dome, something. So here's the problem. Think about this. The direction is 400 kilometers per second is the ether wind, according to that measurement. Somewhere between 200 and 400. Originating at a point in the southern celestial sphere, which you've now, when you map it, projected onto a celestial dome or celestial plane, is somewhere in the sky, and that position rotates once a day. So there's this wind coming down from the dome, going into the flat Earth, and then out of the flat Earth in a very strange pattern. Definitely not, absolutely definitely not a toroid like he had on screen. Nothing at all related to a toroid. It has to come from one specific spot, go down into the Earth, and then curve up all around and come out in a weird pattern, right? And then that rotates around every day. Think about that. And then when I asked him that question, I knew he couldn't, that would definitely pose a problem for him, because to do that actual work would be ridiculous. So, Patrick Butler says, sorry guys, nurse is back, meds time, be right back. All right. MK Ultra is a member at Einstein. Thank you for that. MK Ultra, that's Many Karen. And I was concerned about my friends in Israel. So I messaged, Round Thinker. Hi, Round Thinker. Are you still with us? Watching? Many Karen and another guy, I won't say his name, but another guy on Facebook I messaged who's somewhat in this. All of them were okay. I'm happy to say. So stay safe there. That's a mess. That's a mess. So, Stringer News 1 says, you're spiraling, bro. You pull, the Witsidism. Judy, you got this, says, just to add some excitement, because he is giving none. No clue what he's going on about, but do I ever? Yeah, it was a bit, it's a thicker topic. It takes a bit more to work through it and expand, and his presentation was a little dry. I hope mine was not. Two of them I was reading. I had written up previously, so I try to not talk too drony when I do that. So Patrick Butler said you don't agree. You got the proof. Yeah, that was the interferometer, or the gyroscope on the equator versus south of the equator, was a bit of a stretch on his part, because, and then it was definitely a straw grasp to reject the airplane 3-plane interferometer, because he's talking about the whole computer system on the plane, not just the 3-plane gyroscope. For reference, a 3-plane gyroscope reports its finding to the computer on the plane, and it's not a mini supercomputer. It's not that. It doesn't have to be that powerful. Mini supercomputers don't exist anymore. Basically, like IBM makes some, what used to be called the AS400 and the ES390s. That's not, seriously. An Apple Watch is powerful enough for an awful lot of stuff these days. Anyway, it reports its finding. When you turn it on, you say, hey, what's your latitude? It just reports its finding to the computer on the plane. And so when it does that, if the plane says, well, I know my GPS position is this, you are reporting this, they agree, okay, you are functioning correctly. I know I'm this, and you say you're something else. I know that you are not functioning correctly, or I'm not functioning correctly. Let's check other instruments. Like I said, there's typically 3 sets in the big planes. So you have 3 different multi-plane gyroscopes in the plane. And so it'll go and ask the other ones, what's your position? What's your position? And if 2 of the 3 agree, then we know the one outlier is probably wrong. So let's not use the information from it. If you remember the 737, there was a few of them in a short amount of time that crashed. That was because there was a device on this outside of the plane, 2 of them, just 2. And if one of them read wrong, how do you know which of the 2 is right and which is wrong? Well, the software made the wrong decision and accepted the one that was malfunctioning as the correct one. And it's all digitally done. So the pilot is like pulling up, but that one device is saying, I'm going up already. I'm not going to let you go up. So they're pulling back, and it won't do it because it was reading the wrong data and it went down. Something like that. So that particular, Jaron wants me to come back for 10 minutes. All right. I'll do that. Then I'll get back to the super chats. See what he has to say. When did he say that? Just a few minutes ago.
Sort of
hey,
loser.
I'm back.
Just give me 2 seconds to put Rockfin back up, and we will go. I don't even know if there's a lot, to be honest with you, but maybe people will send them in while we're doing it.
Yeah.
Let's see, we'll start this one. Rockfin, paste. What is today? The 10th at 8:05 p.m.
Hello, Jaron.
Hey, Tune. Sorry, I totally forgot. We spaced it on the questions. Loser.
Okay.
That'd be my fault. I'll take that one. But no, somebody told me right after, and I was like, oh my God, let me just bring back the show and we'll do this. Let's see your questions. Maybe we'll even get more. We'll see. Okay, and we're ready to go with that one. I'm just going to start it and see how many people show up. We're going to go free. Okay, we all good? That's thumbnail, yes. Save. Okay, make sure I have everything done. Dashboard's done. Yes, yes. Okay, I'm going to go live right now. 3, 2, and oops, put a different thumbnail up there. Properties, browse, this one.
So you're not live at the moment?
We're going to go live in 3, 2, and 1. Okay. All right, welcome back, everybody. Sorry, so sorry that we forgot your guys' super chats. All my fault. I thought when Toon said it was over, I was thinking that it was all over, not just that part of it.
You are too suggestible, Jaron.
Yes, I know. It's very easy to get me off the stream. Just, well, that's it. All right, later. Have a good one, guys. We'll see you next week. All right, so let's read through some of these. I want to make sure that the show is on, though. I don't really know. Okay, that looks good. That one's on. Both those are on. Good. And let me get over here. Make sure the stream is going there. No sound. All right. Hopefully we get some people here. It might take a minute. We got one. Encore. Thank you, GG Cash. Welcome. And I will check on those super chats right now. Let's close this and this one. Okay. Let me go check what we've got in the back room here. And
what do you have in the back room, Jaron?
in the back room, I've got a little button that says revenue or something, doesn't it? I think that's what it's called.
Oh, is this on the YouTube?
YouTube. Do you have it? I mean, I don't ever see anybody who does a nice job with super chats. Is there not like an overlay maker? I've never seen any channel do a good job with it.
I have used if this then that to post it to my Discord, and then sometimes I'll use that, but it misses the member stuff.
Yeah, it misses the. I do the same thing to post it to a Google Sheet, but I don't like it either. Just thinks like there'd be something that's better than what we're getting, but perhaps not. Like Twitch has all the stuff you could ever want. Twitch has all that stuff. They're like way ahead in those kind of interactive things. All right, let's go to supers. And then, I don't know if you used to know, there used to be a URL you'd be able to put in, and then you just put the watch code after it, and it would be just a page of super chats and members stuff only. And then they did away with it for some strange reason. So, all right, let's look at these ones. We've got quite a few. Episode 4. All right, good. Hopefully some people that, entered those will be able to catch this part, get their question answered. All right, Michael McToon from Run Boston Bear, $5. Thank you very much. He says, which single axis gyroscope measurement in the Southern Hemisphere have been made to validate the claims you made previously? That is the first one.
Yeah. So single axis, no, it'd be the multi-axis in airplanes. No. And Alan and I went over that.
Okay. So that's the answer there, Run Boston Bear.
Yeah, we had an impasse. Yep.
Okay. We've got LJ who says, would you get on a roller coaster that will go 17,000 miles per hour? I'm guessing that's to you. You probably wouldn't survive, McToon.
Not on a roller coaster, but I would love to go to the ISS. Except for the smell. Apparently it stinks. I don't know. That'd be tough.
Yeah, no, they're in like some basement for a long time, so probably does stink down there. Run Boston Bear, $10. Michael, is there a direct correlation between the amount of outliers we have to throw away and the amount of times we have to lie to ourselves to make relativity accurate?
No, just there's a few outliers compared to a large amount of non-outliers. I'll stick with the non-outliers. But do definitely look at the outliers. I'm not saying that outliers are the things to ignore. But they're not the things to take as the rule.
Okay. Let's go to the next one. And I just started on Rockfin like a loser. All right. Next we've got, if I can find it. All right. Melissa Schultz says, thank you for doing this. All right. You're welcome. And hopefully that's me. Maybe it's to you guys as well. Thank you guys for doing this. We've got Nominal who says, Melissa Schultz, thank you for thanking them for doing this. We keep that trend going. Anybody else want to add to that little train? Demonstride says, Flat Earth is dead. Come prove us wrong at the Medicinal Mass Media Discord server. Jaron, I'd love for you to stop by and have a conversation. Thank you. Demonstride.
Demonstride.
Demonstride. Oh, yeah. Okay. try to not say demon as much as I can, but
I think it is Damon.
is it Damon?
Yeah, he specifically goes by Damon Streed
Oh,
or Stradi. It's French.
Oh.
All right.
dang.
Damon Stradi.
So Flat Earth is dead. Come prove us wrong at the medicinal mass media Discord server. All right. I'm not a big Discord fan, but I do have it. So maybe I need to go over there. We've got another one from him. He says, if y'all have any evidence of non-curve instead of nuh-uh, I'd love to hear it at medicinal mass media Discord server. So we have to have evidence of non-curve. Okay. So if we just say that, measured zero, I guess.
He's
Go ahead, Al.
there, Damon Stradi. No, I was just telling Damon Stradi to he's up there. This promotion of a server. I was just kind of joking around with him.
Gotcha. All right, we're gonna go over to Rockfin and see what is there. Hopefully, I can still find that. Didn't even think about that either. Hopefully, it's still there. I'll check. If you want to ask a question, you have time right now before we head out. But let me see if we can find. Hopefully, it's still there. It should be there. Let's go. This is the first one yet. Let's see if they're still there. Yes, good. They are. All right, let's go. We had a couple tips. Let's check them out. We've got Chris Lenwell, $20, says there's no argument or debate. We're not moving through so-called outer space. These debates are crazy stupid on the part of those like MC Toon. It's so stupid to conclude that the Earth moves through so-called space. It's really that simple. Toon, you have a comment on that?
Well, Dayton Miller disagrees. Right, Alan?
What's that?
Dayton Miller disagrees.
Oh yeah. Sorry, I was tuned out.
So Dayton Miller thinks we're moving through space, you mean?
Yeah.
Oh yeah. Dayton Miller thinks we're moving through space. Yeah, his interpretation of it. Yeah, because when you look at the fringe or how they were interpreting the scale of the fringes, that was proposed by Michelson with their 1887 experiment. So yeah, they all interpreted their the fringe as like within this like 5 kilometers, 8 kilometers, reading per the fringes. But when you look at a stationary device, as shown with Michelson, Gare, Pearson, and what they did with DeFore and Pruner with the stationary lab frame showing the translational motion, it would be the same on a plane it would be the same effect.
Gotcha. And Toon, I know Brenda was confused on this one as well, but she assumes when they say it's a null result to mean that they found no fringe shift. But that's not what they mean by null result, right? The null result is just not what they were looking for.
It did not match the hypothesis. But also the fringe shift that they measured was very, very small compared to what they were expecting. So I mean, it wasn't technically zero. It wasn't
right?
technically zero, but in meat space, nothing is perfect. So actually, if you were to measure a true zero with a high precision instrument, people would typically say something must be wrong.
Yeah, like plus or minus what? That's what the engineers will say.
There's a margin of error in every measurement.
Yep.
Sometimes people don't include that in their analysis, but a better analysis would.
Yeah, absolutely. It should be noted though in Michelson's paper at the end there, they never say that it was a non-reading or null result. They say, paraphrasing here, that there was a reading, albeit a smaller reading than what they predicted, and if the Earth is orbiting, then it must be really slow.
Right. They said it like 1/6 and as far as 1/40th. Right.
Something like that.
Yeah.
1/6 or 1/8, something like that.
Yeah, and then 1/40th is a weird number because it's about 1,600 miles per hour. All right, let me see if we got another one. We got Chris Lemo again. Says McToon, God did not create what you believe in. Let it go. Your feet are planted on a stationary Earth, plain and simple. All right, any comment on that?
I don't care what you say. Just saying things is not all that useful. Maybe Jaron, maybe this person, who is it, wants to have me come on and talk to him on your show, Jaron.
Chris Lenwell. I don't know if you want to debate Toon on. Do you even debate religion? I've never seen you do that.
No.
I
mean, there are plenty of flat earthers that tie flat earth to religion. Apparently,
yes. This
guy does, right? So, I don't know.
Yeah, I think that a lot of people tie it to religion. Does it tie to a creator? I think so, without a shadow of a doubt. But as far as particular religion? I think no. All right, let me just check one more time back here, and that might be it. I'll check the new Rockfin to make sure nobody's tipped on that one. One more time over here, make sure we got everybody. Thank you guys. Sorry about not catching those the first time around. We will learn. Let's see, is there any more? Nope, those are the last ones. All right, Tune, thank you for coming by. I really do appreciate it. Sorry to have to bring you back, and thank you for checking your chat or however you learned to get over here.
Yep. All right.
Thanks, Tune.
Thanks.
Later.
Yep.
All right, Alan.
All right. Okay. Again, Alan did say that, oh, it's just in our model. Like, you don't have a model. You didn't do the math to figure out how that ether would have to move. Do it. Give it a shot. It will be ridiculous. And then, why would that happen? What's the plausible mechanism? The plausible mechanism, if Dayton Miller was right, is that the Earth is moving, or the solar system is moving around the galaxy. That's the plausible mechanism. For him, it just comes from a hole in the sky. Why? Well, then he's going to have to get religious and say God did it. That's about all you get then, right? All right. Live music has gotten timed out for saying anti-vax stuff. So definitely, if he does get on that, yeah. But live music, read the room. The topic is the shape of the Earth. Do try to stick to that, and then I will back you on not getting timed out if you can be an adult and stick to the topic. So, and no, I don't have an email from Live Music yet. So, flap your face all you want, but you can come on right now and set me straight if you think that you've got it. So. All right. Stephen York says he's just reciting Witsit. So much for not appealing to authority and doing your own research. Essentially, it's these other people measured ether, but not at all how I think it works. But they measured it. These small number of things. Never mind. These are not the droids you're looking for. Just these couple. Dayton Miller, these others, 4 or 5 of them. Those are the real truth. The others, way, way better, higher quality measurements. Never mind them. So yeah, it's definitely a Witsit type thing. Though he's a way nicer guy than Witsit. He doesn't quite have the ego. But Witsit didn't have that ego as much. He came into it with an ego. I got to be serious. But his ego has definitely grown over time. So, Carlos Lamb is a new member at Newton. Thank you for that. And Keith Cooney is a member at Einstein. Has a member super chat that says, "Cheers, Flurfs, and everyone that ever existed except them. There's no pride in schooling crayon eating folk in. It's done because the word globe-tart exists." I suppose. I mean, the fact that they would think that they would try to insult. Live Music has sent me an email. There it is. All right, I'm gonna set up a Zoom right now. Let's see here. I'll read the next one while this is going. Serena's one says sync is between 2 clocks, not inside one. Yes. And I did show the graph of the clocks before and after this very marked divergence. Like, that wasn't random. It completely coincided with the movement of the plane. And so what caused it? Random electromagnetic interference? From what? And then that random electromagnetic interference stopped? How? Who knows? All right. I mean, that was a straw grasp, I gotta say. All right. I got Live Music. All right. There's the Zoom link coming in. Live Music. Set your name. I won't say anything once you first come in. You can change your name in the display if you want it to say Live Music instead of your name. So, 2D Res Q explains stuff. So can he explain it in his own words? No. To be fair, citing a good, high quality experiment is a fine thing to do. He just didn't cite any good high quality experiments. To Rescue explain stuff says if he reads any faster, his lips are going to go relativistic to infinity and beyond. All right. Aaron Reese says relativity isn't real. We used it to set off the A-bombs. Well, there's that. Shree News 1 says, I'm convinced text-to-speech requires no intelligence, and anecdotes aren't a substitute for evidence. It could happen, doesn't mean it did happen. Yeah, that was a bit of a stretch on the how do clock squad sync? They just randomly do, and that randomness happens to coincide with when the airplane was flying. And no other time. Melodic Lyric says, did Alan provide a single PDF for any of the papers he mentioned? He did. All right. So if you look at the links, if you look at that PDF, the links that are in there, actual to, DOI links, are the ones I added. The ones that are not linked are typically, though not always, typically the ones that he added. He has on his, he has a GitHub page with all of his citations listed on a page, and then a zip file you can download. That's the citations he has. The papers are hard to find. Many of them are not published in journals at all, or are not in journals that participate in the DOI system. It tells you a lot. So he found them. He has copies of them, and there's a website, Conspiracy of Light, that's an anti-relativity thing, a group. Some of these papers are found on there. MK Ultra says, if he sends you any unsolicited pictures, forward them to me. I have methods to deal with such material. Oh, that's good. All right. So I'm not seeing live music yet. So maybe he's still downloading Zoom or something. I don't know. Nick N says, I hope my fellow Canadians had a good Thanksgiving. Oh, was it Thanksgiving? What's different in Canada than here? Basically, we get together, we eat a certain specific collection of food, and then we sit around the rest of the day saying, oh my gosh, it was too much. Can you get me some pie? Oh, just one more piece. Make sure it's a big one. Just one more piece though. Just a quarter of it. Just a quarter of the whole thing. But it's just one piece and an entire, yes, keep going with the whipped cream. Yep, keep it. Not, don't stop yet. I did not say stop. There you go. And then just finish it off. Get this spatula, scrape it out, put it on. Thank you. There you go. I'm too full to eat this, but I'm going to eat it anyway. That's Thanksgiving here. That must be there as well. Okay. Oh, we've got live music coming in. Getting his stuff set. Stringer News 1 says, there is no Canadian Thanksgiving. The Pilgrims ate with the Indians in Merca, and a month later, Jesus, who's also American, was born. All right. Oh my gosh. All right. Live music. Your name is on there. Are you okay with your name being visible?
On there?
Okay. Yep. Go ahead. Yeah. Now they can hear you. I didn't want to have your name.
I appreciate that, but no, I'm good. I'm not hiding.
All right. So there it is. Hello, Greg. Live music.
Hello, Tune.
All right. We'll bring it.
I really was chatting in there in the room, and I have logic, I have reason, I have years of studying this. I'm not going to pretend that I have your maths or those kind of things like you have in debates with others. And I don't need that for my understanding. It took none of that to come to the realization that we live on a flat, motionless plane. It didn't take religion for that. In fact, it was that truth that brought me back to Christ. So I'm not going to be here to offer what, like, you and others were saying that, oh, it must be, he loves Austin Whitsitt or something like that. No, in fact, I have some great differences of opinion with him. I just know what I know. And when I see you, I get a good laugh. I loved when you went up against Dave and he cut you off because you were spewing such nonsense of these columns. And that was pure comedy gold. I know, like when I've shown my child long ago, when you look in the window and you look at all the dust, when you can see it in the sunlight, everything moving around, you don't have these columns of stuff. Anyway, we have literally zero evidence of curvature or rotation. Everything we observe is to the counter of that.
So
everything
what
we
is evidence of curve? What counts as evidence of curve?
If we could see it some way, we don't. And this nonsense. We don't see too far. We do see too far.
Hold on. So a photograph of the curve.
Something that could demonstrate it. It's kind of comical that you asked me, what is demonstration? What is evidence of the curve?
Well,
if it existed, you should be able to show me in a scientific experiment or on a camera or something like that. To the contrary, we can show you over and over and over and over and over the fact that we do not see curvature. Right. We do not see rotation. Never been measured, never been felt.
I'm preparing so that I can share with you.
You're preparing me. Oh, that's great. I love it.
All right, just a second here. You're not going to get that on screen there.
Yeah, I thought you were going to. Yeah, your Tune keeps cropping my shirt because he likes to censor just like his little trolls.
So, all right. So,
you afraid the AI, that the algorithms are going to pick up those words that I drew onto my shirt?
I just read the room.
Oh, okay.
Room. All right.
Maybe if I had some Legos spelling it out in the background, it might work.
A photograph of the curve. There you go. There is a photograph.
That's not a photograph of the curve.
Whoa. So is what your response is, huh?
No, you're the nuh-uh guy, just like the rest of the whole, you flat earther. I mean, you glowers.
All right. Well, I mean, there's a photograph of the curve.
No, it isn't.
Well, what is it then?
Okay. What would you say when I show you countless examples of other photographs? And you're not going to show me again either. Photographs that show it flat. How do you? I mean, this is absurd.
So
we have seen.
Seen a photograph from 46,000 feet.
Hold on.
With a rectilinear lens. Bring it up. But this is 46,000 feet, rectilinear lens, curved horizon.
Wait, did you go out or did you just? You there?
I'm still here.
Okay. 46,000 feet?
Yeah.
Okay, that equates to what? Is that 8 miles approximately? Is that right?
How many miles in elevation from 46,000 feet?
No, I'm asking. Yeah, so what? It's like 5,200, 5,200 something per mile, right? So what is like one of your alleged heroes say is that you can't see it? Like what elevation did what's his name Baumgarten jump out of that?
Yeah, Felix jumped out, and Felix himself said he could see the curve of the earth. But that's a different thing. Here we are looking at the curve.
Was that?
You specifically said that there are no photographs of the curve.
Is that? Don't
is
steer away. What elevation did he
46,000
allegedly jump at?
46,000 feet is what we're looking at right now.
What did he allegedly jump at?
Baumgartner?
Yes.
I don't know.
Is it higher than that, you think?
Yeah.
Okay. And what do we see when we look out of his little capsule? We see a flat Earth.
No.
We see a curvature only from the fisheye lens. We see what was that, Arizona? We see what is Arizona looking like it's the entirety of
so
half
this
of
is
the
all
Earth.
one giant deflection. Everybody sees through it. I am showing you the curve of the Earth right now.
No, you're not. You're not showing me anything.
Well, what is this then? Why is that horizon curved?
Oh, okay, then let me ask you again. And I know that's not always right, like to come back with a question for me. I don't know what I'm seeing here. I'd have to look further into it. But I'd have to look at the camera, and I'd have to look how it's angled. There's different things going on.
Mm-hmm.
That doesn't change reality.
Okay.
When I look at Felix Baumgarten jumping, and I look out of his window, what do you say about when we say a level horizon
deflection.
out of Felix?
That's just deflection there.
No, you're the one that was trying to deflect
That's
when you
just
didn't want to go in this direction. You're staying away from this. You'd rather go back to your
specifically
silly
asked
columns.
for something.
Your silly little columns of air.
I gave you exactly what you asked for.
You're a joke.
I gave you exactly what you asked for, and you didn't want to see it. You just have a nuh-uh for it.
No, you didn't. You didn't prove anything.
What did you ask for?
I'm trying to have a conversation. Like when I got on here,
what did you ask for?
I don't have your. Hold
That's
on.
Fine. There's no math involved
kid.
Here. What did you ask
Settle
for?
down, kid. Settle down. Can you calm down and listen to me?
Go ahead.
I am not somebody that goes on debate shows for a reason. I don't know all these specifics of math and this and that. I don't try to pretend that I do. I don't need it. I don't need somebody to tell me the math that I'm going to be safe walking across my floor, that I'm not going to drop down into some pit. I don't need somebody to tell me something about, the obvious. I know what I can experience. I know what I can see with my P900. I know what I can see with my own eyes. I know what I experience, which is not anything. There's no sense I've ever felt in my life of feeling rotation. I know these things. I don't need to go to that level. You all only have nonsensical stuff like that. But on the other hand, we can bring up countless photos, countless videos, our own experiences, actual math, actual science. And then you bring up like a random little photo here or there. I brought up Felix Baumgartner. You admitted that, yes, that was higher. What do we see out of that little capsule? We see flat.
No,
what do? You tell me that I'm deflecting.
We see a GoPro camera.
No, you see two cameras. You see one shot that is totally makes it look like Arizona's half of the Earth. And then you see something that looks approximately level. We can see our own eyes every time we go in an airplane. What looks level.
Okay.
That's what we experience.
So you asked for the curve.
You can see.
I gave you the curve.
No, you gave me one picture. You didn't give me curve. You have nothing to support your nonsense.
So you're blindly rejecting that this is curved. Is that curved? Yes
no, I'm not denying that what we look at in the picture is a curved line.
Okay,
that doesn't mean anything.
Okay. Here we go.
That doesn't mean anything.
Here's just for reference. I just want you to
just like when that Ruhis buddy of yours tries to show stuff with his laughable.
Here's center frame, top of frame, bottom of frame. Curve is the same in all directions.
You have nothing.
There you go.
No,
this isn't nothing. This is the curve of the Earth.
So
look at that.
Okay, so should I start pulling up? Should I start pulling up long distance? Like that's the thing is you all think that
you introduced this topic. You specifically said you specifically claimed
this is our discussion
that there's no curve,
that there's no curvature or
and
no rotation.
I'm showing
and
you
were
the
trying
curve.
to say that I am the one. This
I'm
is
showing
the topic
you the curve
overall that you were on that debate for. And you're trying to pretend like I'm the one bringing up this topic.
You introduced this topic 100%. You said you made the claim that there are no photographs of the curve. I said, here you go.
Yeah, there aren't.
Right here, we're looking at it.
That doesn't show me anything.
So, nuh-uh. That's all you have.
That does not show me anything. You know what's more reliable? Seeing this, where I don't know about the optics of the lens.
Mm-hmm.
I don't know about how calibration.
I'm showing you about the lens.
Can I continue to talk, Mattoon, or are you going to act like a jackass?
Look at that. It's not the lens. It's not the lens.
I'm telling you, I would need to know a lot of different details. And again, this goes into what I admitted at the beginning. I don't know certain specifics. I'm a professional photographer and videographer. I don't know certain specifics about things of lenses that would be even a factor in this discussion.
You are a professional photographer?
You're showing me something.
Wait, you
look
are
at that
a professional.
image.
Hold on.
I am. And
you are a professional photographer, and you have a P1000.
I have a P900, so not quite a
P900.
1000.
Okay. And what gear do you actually use when you shoot for money?
I don't use the P900.
What do you use?
I use Canon C70, R5,
Okay.
XF705, rent others.
Okay.
I also understand lighting, and I also understand when I go to Adorama or B&H that if I want a light modifier, I have and will never see a spherical light modifier like the moon. The only time you see a spherical modifier is when the light is from within it. So I do have a couple of lanterns, and you put the light within it. There is no such thing as a sphere that reflects light the way the moon does. That's another discussion. You brought that to my mind in this direction, that I do know a lot of things. I don't need to know your nonsensical, laughable. No, you're a joke, dude.
All right, here's
you're
another
joke.
one.
Hold on 1 second. So long distance photography. You're going to show me these photos and act like that's proof something.
I mean, you're the one that said
you're
the one that said there's no photographs of the curve.
No, Mattoon, I have not saved them on my phone. You know, it was an older hard drives where I used to save stuff like this. I don't have quick access to photos from airplanes that show the horizon. There are many photos and videos that show a lack of curvature from such elevations. And so who's right there, right? I'd say that what our experiences are, what we can see from those. What do you think? You may say Jay Tolan is a trolling us. You can't deny what he sees. You can't deny what we see in long distance photography, from photographers that have no role in this game. They're not flat earthers or otherwise. They're just out there shooting this stuff. We see stuff that should be hidden by many miles. And you're going to pull up a photo like this. Oh, that destroys that. Toon, you're a joke, man. This is 2023.
Curve of the horizon.
We have known for a long time there is no evidence of curvature. And then you all you jokers talk about what's his name.
Evidence of curvature right there. Look at that. Amazing.
Pull up Jay Tolan stuff. And what are you going to say?
About Jay Tolan? Jay Tolan's photographs of the horizon are curved as well.
I'm talking about when he can see stuff that is hidden by what should be buried by miles of land.
No, and then the other problem, Jay Tolan never can identify things.
Answer that. Jay Tolan or anybody else that shows land that should be hidden
they never
by
do
your alleged curvature by more than miles.
But Greg, Jay Tolan can't identify things for crap. He says,
identify things. We see stuff where we can see literal structures.
There's
of
blah,
skylines.
but it's not.
How about the skylines? where there's no? Are you arguing that somebody just
Jay Tolan didn't identify skylines?
The ocean put up.
Jay Tolan doesn't have skylines from his airplane videos.
You're a liar. You're a liar. There's one of them where he shows a skyline. It's not his super long distance from an airplane. It's from the land.
So it's not from the airplane. Okay, got it.
And you can see a skyline that should be hidden by much land.
Should be hidden. But you don't do math. But hold on, you don't do math.
Refraction works in some magical way where it brings up.
There you go.
Curve. Like right here a little bit, and here it brings it up higher, and here it brings it up a little higher, and here it brings it up higher, and here it brings it up higher, to where it all looks like it's. Dude, Toon, you're a total joke.
Curve of the horizon.
You are such a joke. You're such a joke, man.
I mean, seriously, people are going to accuse me of bringing on a fake flurf to
make
flurfs look bad. Oh, look, here's another one.
No, Okay, whatever.
Look at that. Another
Tell
one.
me about
Let
tell me about your magical columns
It goes on
that
and
separate. Tell me about your
There you go.
columns.
on. All right.
Oh,
So-
yeah, that's not a. You know what size the Earth would be if it was that shape that you just showed me with the Concorde? You know how small the Earth would
Tell you what,
be?
let's have a look here. Here's the analysis.
Oh my, are we going on a beach ball tune? Oh
All
my
right.
gosh.
Here you go.
Oh my gosh, that's so comical. Are you gonna show that again, please? Please put the Concorde photo up there again.
All right.
Oh, please, McToon.
Here is.
Please show us that,
Sure,
and then
sure.
tell us about your columns of air.
There you go. There's the Concorde.
Come
photo.
on. No. Oh, okay, I guess the delay. There we go. Okay. Oh, look at that. Oh my gosh. Oh my gosh. That Concorde, in fact, I'm surprised we don't see it bending along with. That's incredible. That
All right.
is a.
So here
I
is.
thought the Earth was what, 24,000 miles in circumference?
Here you
Is
go.
that it,
For,
McToon? Is that it?
yeah.
Is that it? Is it
All right.
like 24,000 something
Here
miles
you
in
go.
circumference?
Here you go.
Go back to the
Scaredy guy.
Concorde one. Go back to the Concorde one and tell me that was 24,000 miles in circumference,
All
and
right.
that we're seeing curvature.
Dude, you already said you can't do math.
That's awesome. I love it. So you have to show us things like this because you show the
right.
real picture and it destroys your
All right.
little nonsense.
Are you ready? Are you ready? Here is the analysis. You don't got it?
Oh,
You can't take it, huh? All right, here's the actual analysis. This is gonna.
Dude, you're gonna delete this, right? Because then nobody that doesn't know math or anything
No,
is just making a fool of you.
no.
Oh yeah, we'll see if this
You are
stays
making a
up.
fool of all flat earthers right now.
We'll see if this stays up. This is classic. Oh my gosh! And please tell me, like you told Dave, about your columns of air. Oh, please go into that again.
He turned into a chicken pretty quick. But let's look at this here. Here is the actual prediction based on the globe for this photograph.
I love it.
Sure you do.
Oh gosh. Oh, this is amazing evidence. It destroys all reality. There, Toon.
It destroys
Oh
flat
my
Earth
gosh.
is what it does.
I all
because
of a
this
sudden
is-
feel like I
this
am
isn't-
spinning. Like whoa. Oh my gosh. Woo. Spinning.
Shovelhead Steve,
Oh my
you are
God.
100% correct.
Oh my gosh, I'm spinning so fast. That's funny. In fact, that
100%
spinning that little
correct.
bit in my chair, I felt a lot.
All right.
But going the speed we allegedly are, we don't feel it.
All right.
I don't
here
need
you
math.
go.
I
Here you
don't
go, Greg.
need Witsit's math. I don't need McToon's nonsense made up stuff for these
This is-
laughable images.
This isn't made up.
I
This
have
is real
reality.
application. Real application predicting what we would see for a globe of 6,371 kilometers radius. That's what this is here. And the photograph matches.
What else
Right
do you
there.
have, McToon?
Well, you specifically
Well,
claimed
no, I'm asking
there were
you.
no
I'm asking
photographs.
you.
You
Okay,
specifically
okay.
claimed there are no
Okay.
photographs of the curve.
Okay,
I showed you a
I
whole
don't
bunch,
agree with this,
and
I don't
all
agree
you
with
did
this,
was
but I'm
say
telling you-
"nuh-uh" a whole bunch
Okay,
of times.
you got me with that. You got me with that. I don't agree with that, but you got me with that. Okay, let's just like you would do in a debate, and you would say, "Move on." Do you believe? Let me ask you this: if you're so worried about my focus on my questions, do you believe we landed on the moon?
Certainly, we did.
See, you just lost right there. Do you believe there's an international space station and people up in there?
I got video of it traversing the sun.
Oh, beautiful, beautiful. That tells us what we're seeing from their videos must be what we're seeing in the sky. Those two equate. Is that right? So if I tell you
It's
that there's
confirmation.
something in
It's
the
one of
sky,
many.
and I
It's
show
one of
you
many
another
lines
video,
of evidence confirming it.
could I fake something with my high-end video equipment in my home and make it look even more advanced than what David Weiss does, which is pretty clever stuff?
No,
Could
you
I
could
not, with green screen, or even
you
what
could
Dave does on a regular basis,
No, you could not.
make it look like you're in a room doing that? And I
No,
can
you
tell
could not.
you that I'm up in, oh, I could not. Oh, okay. Oh, you're right. You can't fake being in an ISS. You have to be there for it to be real.
That's correct. Yeah, you could not fake an entire hour-long
you're
uncut
awesome.
video. All right.
You know what? Hate is a strong word, and I'd never want to say that to anybody. I will pray for you. I love you, man, and I love you even more. I used to not love you at all, but now I love you even more because the comedic relief that you bring us in these horrible times is so, it's so welcome. It's good. And that you bring so many more people on a regular basis to the reality of flat Earth. Just even if
All right.
they couldn't see,
so
where I
let's
was
look
coming
at
about
let's
the
look
last
at
first part of the discussion,
the evidence.
the fact that
for,
you said that
hold
you
on.
believe in the moon landing and the ISS.
Let's look
that
right here.
alone shows you're just a fraud.
Let's look right here. Third
Oh,
party.
yeah, you won't let that on there. There we go.
Third party photographs.
Well, here, yeah, you won't. I can't hear you right now.
Okay.
Yep.
All right.
All right.
Ready?
Now, third party, what?
Yeah.
Yeah. Hold on. I got my earphones back in.
All right.
Let's hear your jokes.
All right. Third party photographs of the moon. This is run by Arizona State University. All right. You see this here?
Oh, a university?
Yeah.
Oh,
so
wow.
this is Apollo 11.
Man. No,
site
wow.
right here.
That's
you can see the shadow of the lander there going across that crater next to it.
Oh,
You see that?
wow.
All right.
That's
and then
so
the shadow here
amazing.
reaches almost to the crater.
You know what that reminds me of? You remember when they showed us those photos of that space, and is it Arizona or whatever? And then the space on the moon, and they said that they wanted the astronauts to be able to experience the exact same thing. So they replicated the exact same so-called craters and stuff. And what we see on Earth, and they don't deny this, looks exactly 100% identical
Except
to what
it
we see on the
doesn't.
moon, because they said that they did such a good job with it.
All right.
Okay,
Except
I'd
they
say
did.
98% identical.
Okay. So
That
there, and
reminds
then
me
you
a
can see
lot
the
of that.
shadow.
Oh,
you can see the
man,
shadow on the
that's-
other side. So there you go.
Oh,
This is
wow.
third party.
Not only do I do video and photography professionally, I've been playing with Photoshop and everything else for years. And we know that they have trick stuff that they've been doing since the 1800s, if not, I mean, so
1800s.
what are you showing me?
1800s,
What are you
huh?
showing me?
Here's
Yes,
Apollo 12.
1800s.
You can see the footprints.
1800s, yes. From the 1800s, they were doing stuff, trick photography stuff.
All right, there you go. There you can you can see the
oh
the
my
shadow
gosh, that totally
going over.
proves the moon landing.
This
Changes
is
my
one
mind about everything.
this is one of multiple lines of evidence.
The fact that there's no impression on the Earth. The fact that
an actual skeptic looks at evidence and considers evidence,
a couple layers,
and looks for
aluminum foil,
for multiple lines of evidence. So if you're going to be honest, then this is one of many lines of evidence that you would look at.
That's the thing about you. There are honest globers.
So there you can see the shadow getting longer.
You're not an honest glober.
And you can see now the shadow going the other direction.
And that's what makes you so evil.
Is that all
there are honest people that are deceived.
You've asked for evidence. I'm giving you evidence.
You're not giving me anything.
This is, and your only response is denial. Got it.
What a joke.
Now, India.
I am not okay. If I had the opportunity to, if I had the opportunity to, which I don't have it, which you're prepared for, just like I told you at the beginning, I'm not prepared with my maths. I would have so many more videos of photographs that are even from your side that would destroy all this laughable nonsense you
but
push.
You don't have.
You're a total joke. What do I don't have? Anybody can look it up. Tell me why the boot prints don't match.
Here is the
Tell
boot
me
prints,
how he almost. I ran video for a conference for a few years where NASA was like one of the lead roles.
Do match.
No, they don't. And then you've got this lander that they
all
say
you have is
$22 million or something like that, right? With this little like umbrella on it and some lawn chairs, and we don't see any tire marks from it at points.
But we do see tire marks.
We see no thruster.
So here is India's photograph.
Tell me this. Oh, we're gonna go to India. Oh my gosh.
India's photograph. There it is.
Oh wow! You just totally. Oh my gosh! You destroyed the fact that the sound from the boosters alone would have blown people, made them deaf, and that they couldn't even take off in that.
They would not. Again,
you've
already said that you don't understand the math and science.
Oh my gosh, that's right. I forgot that sound would be so loud that people have to be many, many miles away, but they can just hang out there and have a little pointer and touch little buttons. But that picture, you did it, Toon. You changed my mind. I now feel like I'm spinning again. I feel like it. I'm spinning. Whoa! I'm spinning.
Right.
I'm spinning, Toon.
Here's 15,000 photographs
Toon,
from
the
Apollo era.
You're such a joke that you have to be on with a nobody like
this
me.
This particular photograph.
You're a nobody.
This particular photograph and all other 15,000 of them are
I'm
in.
A nobody, and you're.
Yeah.
This photograph? Nobody. They don't admit that could be a photograph. What are you talking about?
Of course they do. This is a photographic slide.
No, they say an image.
No, this is a photographic slide housed in a museum in Houston, Texas.
I'm in Houston. Show me where I can go find that damn thing.
Excellent. I will get it.
Does it not have repeated clouds?
It does not have repeated clouds.
Well, you tell me why.
You're just parroting. You're just parroting your Papa Flurf.
No, it's not parroting. It's not parroting. If I repeat something that other people said, that doesn't mean parroting. If 2 + 2 is 4, somebody else saying 2 + 2 is 4 doesn't mean they're parroting.
Good job, but you're just
parroting reality
because you didn't look at this to see if there's repeating clouds.
You just pulled it up on screen. I asked you the question.
Yeah. And by parroting, exactly what you've heard from your Papa Flurf.
I asked you, are there repeating clouds? Is there a good reason I would say that? Yes. Because let's look at history. Let's look at what they say are images and what have repeating clouds in it. Is it so absurd that I would say such a thing?
Yes.
You're such a fraud.
You're
such a fraud.
I'll put it in the live chat.
No.
There you go.
Stop.
Go
back to that.
Go back to that.
Go back to that. Quit
go
moving
back to
on.
This.
Slow down. Go back to that. Is that Africa? Will you zoom in?
Yeah, let me download it.
Okay, so we're looking at Africa that's taking up. Is that the only continent we see right now?
Just a second here. I'll zoom in.
What do we see? You don't even have to zoom in. What do we see besides Africa there?
Well, you've got Antarctica on the bottom there.
It's pretty well covered by alleged clouds, right? So we can discount that, right? We don't know what's under there. If that was a real photo, we don't know what's there.
There's Africa.
What do we see?
Madagascar. There you go.
Okay. How much of the rest of the Earth is not shown? And are we not seeing
more than 50% is not shown?
My question, loser. Are we not seeing more than 50%? I mean, are we not? We should be seeing 50%.
No, you should not be seeing 50%. If you knew anything about photography, you'd know that if you're close to a subject, you don't see all
by
of
the
it.
way, and look at the left. It looks like there must be a spacecraft off on the left there. Look at that little thing floating around. By the way, the first time I used a P900, on a video on the moon, I actually captured a satelloon, balloons holding it up. I don't have access to that right now either. I'm not trying to prove that since I can't show it. But anyway, so what we're looking at is one continent and a little bit more, and the rest of the world is hidden. And I don't need to be a photographer or anything else to know that if you look at a ball like that, if I look at a basketball and it has a logo Spalding on it, for example, I can turn that logo all the way around to either side, the top, bottom, and I will still see part of it. It will be distorted, but you're telling me that we should only see that the rest of the world is on the other side of that ball?
I think you don't quite understand photography as well as you've claimed that you do.
Oh, okay, that's right. I can't take portraits. I can't do video interviews. I can't do that stuff without studying the effects of shooting a sphere. I'm sorry, I don't shoot spheres all the time.
There's
But I don't,
the
again,
same.
back
There's
to
the
the beginning
same.
of my discussion.
Here's the
I don't
same
need
ball.
to have your math.
Here's the same ball photographed at two different distances. Do you see the top one there where how you don't see as much of the ball?
Oh, wait. Did they get up real close and use a wide angle lens on
Exactly. Yes, exactly.
No. Let's compare the distance of what they did there. Because I do know about macro photography. I do know about getting back. And what we are looking at in no way equates to what's on the top of that ball. In fact, their lenses are very equivalent to what I have in my closet right here. And there's not a chance in hell they have anything different than what I have in my closet, especially that they would allegedly bring up on those alleged spacecrafts. So you're going to try to tell me that it represents what's in the top one. I call total BS. You know how wide that lens would have to be and how close they would have to be to have that? You're the one that does not understand
the
photography.
data.
You're
the
the one
data
that
is
does
all
not
available.
understand lenses.
The data
You're the
is
one
all
who's
available.
A total liar and a total fraud.
Go ahead,
data,
Mr. Photographer.
No.
Get
back up. Let's
get
onto
the
that.
details on how far away it was. Hold on.
Go back to that.
The details on how far away it was, and the actual lens is documented. The actual lens and camera body they used is documented. You can go look that up.
Just like they documented what they used on the moon, and
you
it was
can
destroyed.
And
like
you
by
can
that
back up your
photographer.
claim, or you can
Gary
run away
Fong,
from your
Gary
claim.
Fong destroyed.
Gary Fong's an
Gary
idiot.
Fong totally destroyed. Oh yeah,
Gary
he's
Fong
an idiot.
is an absolute
He knows
idiot. Yes, he is an
photography
idiot.
a million times more than you do.
Gary Fong.
No, he doesn't have a role in this game.
Gary Fong
and
thinks that a rock, a rock can block 5G without being in the way.
What does that have
to do? He
with?
doesn't he's an idiot when it comes to science. He's an idiot when it comes to science. He didn't.
Discussing a
Gary Fong's
camera.
Gary Fong's talk had nothing to do with optics. Gary Fong's thing was only about his misunderstanding of the lens and the camera that they were using. That's all that he was talking about.
He went into great detail explaining.
And he was all
the
wrong
BS
on it.
Camera.
Yeah, he was all wrong on it.
Dude, this is nonsense. You're a fool. You're a liar.
Yeah, Gary Fong is not very bright on this topic, but he's going off on
brilliant on this topic.
No.
Go back to this.
He isn't an expert.
Go back to this. Why do we only see Africa basically there?
And I'll tell you, it's that. That's why. Why is this hard?
No.
If you knew anything about photography,
okay, so
you'd look at this and you'd say, "Oh yeah, that makes sense."
That doesn't do anything. Go back to that photo. Keep it up. Keep it up with the balls. Okay. So I'm seeing it. Wait. Okay. There we go. Even with that example, you project your globe onto the bottom image, I would still have a huge problem and tell you that there is still tons and tons and tons and far more than 50% of the land that we should see. But you're just going to yell out mass or gravity or some nonsense.
No, I'm just going to point to this picture
you're an evil.
I'm just going to point to this picture here.
Evil human. And I sure hope you don't have any children because you're so evil. That's so sad. Why
are you such an asshole? Why do you have to be like that?
You're so evil. You're so evil because you're a deliberate liar.
I'm specifically explaining how this
does not
explaining
show anything. Okay, show me.
This does not show all of the Earth, and this is why it does not show all of the Earth.
And what did I just say? I explained that's not an answer. Back that up. Give me. Okay, let's be very generous. Let's give a little bit more of the Earth. If we backed up, show me how that picture does not compare. The distortion does not compare at all.
What distortion?
That we're seeing in the top lens, the top of the dribble up ball.
Yeah.
That does not compare to, and then where was that photo from allegedly taken from? Is that one of their,
this
which I would say was
dribble
probably,
up ball? I don't know where it was
No.
taken.
I'm saying the alleged photo of the Earth. Where was that? Was that taken from an alleged satellite or the moon or what?
No, it was taken by the people in the Apollo 17 capsule.
Okay. Oh my gosh. Well, so Toon, I began my awakening.
All right, no,
I opened my eyes back in 2005.
I don't care to hear your come to Jesus story. I've demolished
that I
every one of
realized.
your claims.
You haven't
and-
demolished
and-
anything.
Yeah,
You've given your little
certainly have.
nonsense children that
So
follow
on-
you like.
This is a good question.
You haven't given anything.
On Saturday, the Globe predicts there will be an eclipse.
Predictions a week. How do you think they did it for thousands of years before
They
they even
never,
had the idea
for
that
thousands
there
of
was a
years,
ball?
they never got the location.
Oh my gosh! This whole idea of a globe is
They never got
relatively
the-
new,
they never got
speaking
the-
to everything.
They never got the location. All of the analysis that predicts the location, time, duration of the eclipses is based on the globe. The only thing they could do before they used the globe geometry
Blocks me, freezes me
was
up.
to get the
Thanks.
specific day. That's it.
Dude, this whole idea of predictions.
So here you go.
You're a joke.
Please explain how the flat Earth model
You're a
predicts the
joke.
time, date, location, duration of the eclipse that's coming on Saturday.
You're a joke. They've been doing it for thousands of years.
Oh, you'll need to back that
They've
up
been
then.
predicting it. Well, again, as I preface when I came on this call, I don't know the maps. I don't know all these different specifics. So I don't.
Okay,
bring up
so
dates. I don't know
then
a
why
lot of
would you
these
make
things.
that claim then? If
I
you
don't
have
need that. It was your
course
little
you do.
followers that were like, you suck. And what they kept on continuing to censor me nonstop when I wasn't even being rude. They censored me over and over, and then they attacked me like, you won't reply. I'm like, I can't reply. I'm censored for 5 minutes. You all are a joke. We don't do that on the flat Earth side. Unless you really come in with some
of course you
really
do,
jerk content for the most part.
But that's 100% what David Kane did. He turned into a chicken. He's a were chicken. That's the one claim.
Up columns of air.
That's the
are you
one.
kidding me?
That's the one
really,
claim that he
McToon,
said that actually was true. He did turn into a chicken.
Columns of air.
Of
Are
course,
you standing by that?
Of course, 100%.
So is this a column? Like what's a column? So what happens when I taught my child years ago? Not taught, but just showed them to observe, looking in the window when we see dust flying all around the place. Aren't those supposed to be separate columns that are distinct of each other, like having little walls up?
What?
Your columns of air argument.
Yeah.
Are you suggesting? So you're standing by that?
Yes. He wanted a column.
What defines a column of air?
Whatever you decide.
Air pressure has to have containment.
No.
And your
not a physical
response was this nonsense in your room. First of all, before even the column stuff, you were talking about, look, does this need containment? You have a ceiling in your room. You still have the containment that I claim is a firmament, something overhead, far, far, far above.
With no evidence,
and you're
of
acting,
course, yeah.
and you were acting as if we should equate things down to, I don't have a container right. I don't need containment right here. I'm like, there's a ceiling on your room.
No, but side to side.
Again, there's
between here and here, there's pressure between here and here. And there's no actual physical container between them.
I thought you were saying that these are physical columns. So what differentiates it?
So to review,
so are you suggesting?
I'm going to review. Let's review. Hold on. He asked for a containment without a container, or pressure without a container.
You can't have that.
And that's what I gave him. Yeah.
You cannot have pressure without a container.
Well, so you say religiously with no backing evidence.
No, there is no.
Then bring forth.
There's no
bring forth the evidence.
Otherwise,
bring forth the evidence supporting your claim. You are making the claim. Just like David
I have never, ever seen in any debate brought forth by you or anyone else that you can have containment. I mean, that you can have pressure without containment. And the best you all can do is say, there's pressure gradient.
That's all we claim. All we claim is a pressure gradient.
So they're still pressure. Understand that pressure is part of the ultimate pressure gradient.
Yeah, that's all we claim is a pressure gradient.
And as has been proven, you can have a container and have differences in the pressure within that containment.
Yeah, and what causes that pressure?
This size that I can fit right
certainly,
here.
And what causes that pressure differential?
You were so absurd is that you were having a cup
what causes that pressure differential
and
inside
you said,
that sealed
I've got
container?
this thing in my hand this is contained right here.
What causes that pressure differential inside the container?
Are you suggesting that there's a difference?
You want to run away from that. You don't want to answer that.
Again.
You don't want to.
Again.
What causes the pressure differential inside that container?
there is no differential from your columns from here to here.
No,
to
within
here.
that container you just described, what is the pressure differential caused by?
Let me go back to the beginning of when we very first got on the call. I don't have all the maths and all that nonsense.
You're just making claims.
I know that I'm not making. I can make a claim that my hand is in front of my face. I don't need you to give me some maths or tell me about refraction or gravity or something to know that it's right there. I'm not a moron like your followers.
I disagree.
So hold on. I know that there's not a column of air here that's different than this. I know that it will disperse evenly. I know that there are plants that give off their gases. But it doesn't disperse evenly. I know that we give off our gases. I know
it's not even.
On Earth,
there's a pressure differential. It's not even.
There's a constant process on Earth that is called life cycle that goes on, where there are different gases going on and off the whole time.
Inside that inside that sealed container, there's a pressure differential.
In Houston, unfortunately, we have power plants not far away that push out a bunch of different stuff. So there's different
you don't want to
things
answer
in
the
different
question.
areas.
What causes the pressure differential inside the sealed container? Inside, no, you're not
answering it right now. You
inside
dumbass.
the sealed container. What causes the pressure differential?
The firmament is the sealed container.
No.
Take an
actual sealed container.
Dude, shut up and listen to me. You're the one that's afraid of a nobody talking truth because you're making up crap. And your troll days are numbered. Your troll days are numbered because you're evil. You're not like the honest ones. Come on, and actually have a real defense and ask real questions.
You got nothing.
You were obviously paid. You're a controlled shield.
You got nothing.
You put up this nonsense.
All you do is play the shield card.
You interrupted me and then you say that. So
shield card. You play the shield card when you don't have evidence.
Shut up, Tron. There's a firmament. There's a solid structure.
Claim without evidence.
There's a solid. I hear thunder. I see rainbows. I see sprites.
None of that makes any sense. None of that requires.
It doesn't make sense. Yeah. For your cognitive dissonance, it makes sense to you because I know you know it because you're a liar. You understand it. You know it's flat. You know there's no curvature. You know there's a dome above.
Yeah, deflect.
But for your flint,
inside a sealed container.
Tell me deflect.
Inside a sealed container. What causes the pressure differential?
I keep answering. You keep interrupting. You jackass. There is a dome above.
No. Don't. Just in any sealed container.
No. I'm
get a sealed container in your room.
You don't like my.
Get a sealed container in your room. What causes the pressure differential?
Let me answer you. Can I answer you?
You haven't. You keep deflecting. You're going to deflect again.
Can I answer you? You don't like my answer.
Go ahead. Without deflecting, what causes the pressure differential in a small sealed container?
Columns. That destroys your little columns.
What causes the pressure differential
the way I want to answer?
Inside a small sealed container?
Remember, I'm a nobody. I'm a nobody.
You're going to deflect.
I'm some top scientist.
No, I'm using you.
Are you going to let a nobody say
there is no flat earther with a PhD?
Are you afraid of it?
In a relevant topic.
Oh my gosh.
So go ahead.
You're
going to run, but I'll let you run. Go ahead.
You're nobody. You're nobody. Oh my gosh. You're nobody.
Come on.
I'm a nobody.
Jump to it. Hop.
Oh gosh.
Hop.
So. Oh, you blacked me out.
Waiting.
Oh, you blacked up my screen?
Waiting.
Lovely.
Because you're too much of a douchebag to stay on topic.
Oh.
So, all right, go ahead.
Okay.
Go ahead.
I was the one that kept trying. Oh,
go ahead.
Okay. So the video
what causes the pressure differential in a small sealed container?
You won't show a video of me because you don't like my shirt. All right.
What causes the pressure differential?
With all your little nonsense, little kids.
What causes the pressure differential in a small sealed container?
Listen to me. This is okay. Can you please shut up for a little bit? Well, can you agree with me that you'll shut up for a second? I don't want to start talking until you agree that you'll shut up.
Go ahead.
Okay. Back to what I said when I got on. I don't know certain scientific terms like you might, like everybody you debate might. Like other people on your side might. I don't pretend to. I got into this because I was in your chat And people were so fixated on me and said I was a wimp for not coming in. I was censored like mad. I said, I'm not afraid. I'm not afraid. Truth fears no scrutiny. Your question, I don't know what kind of an answer you're looking for. I'm talking top level. What causes the gradient as I see it? Somebody could correct me on it. That's how I came to learn, is from questioning things and moving from there. That's where I got to the point I am. I've learned how to think better and better over the years. I see that there is a solid structure ahead, way, way, way above. Do I know the distance? I don't know the distance. Do I know exactly how it's made up? I don't. What I do know, what I do believe is there is that solid structure above. I also do know what goes on Earth, which with us expelling us breathing, the trees doing everything doing what they do. The plants, like I said, here close by in Houston, putting stuff out. So there's always the heat coming off the concrete in the city. There's always different gases, what they spray in the sky on a daily basis all around. So things are changing, and usually those are at a lower level. There is a gradient from all different kinds of stuff that goes up towards as you reach the firmament. What causes that? It's how those different chemicals or whatever it is, how they relate to each other. Just like we've all seen within a test tube, for example, with all the different oils leveled out, right? And they all float at different levels. You put a ping pong ball here, you've got different colored stuff. Basically the same type of thing. I do not believe, as you were suggesting, that there is some differential gradient here within my room. Like you tried to pretend there were these absurd columns of air. Oh, let's pull up that app. Yeah, that's going to be so different. Yeah, you got a different column of air here and here because the dust particles from your skin, when they come off, they stay right in that column. And then you really have to bust through that column to go into the other. You're a joke. You don't prove anything.
All right. 14.1310. 14.130605. Pressure differential right here. There's no plants down on the floor here, and the flakes of skin aren't adding pressure to the system. So inside a sealed container, in fact, there's a pressure differential.
Yes, and I already mentioned that. Of course there is.
In a small sealed container, what causes that? What causes it?
Of course we can have that.
What causes it?
I don't know the science. I know it can happen. Like I've seen it proven, like I said, in something this size, we can have a pressure differential.
Yeah, what causes
it still needs a container tune.
No,
the pressure differential does not need a container. No,
what causes the pressure differential?
If there was no containment,
what causes the pressure differential?
It would always equate. If there was no firmament above us,
but it doesn't.
Everything that we experience would dissipate evenly out into the void that you believe exists.
Yeah. Lacking
There's
whatever
nothing that would keep it. There was nothing that would keep it in.
Lacking whatever
Your
keeps
idea
us
of
down.
gravity is a joke. That gravity wouldn't do it when the magnetic force is many, many times greater than your alleged gravity.
The magnetic force?
Electromagnetic pull, the negative pull of the Earth, is greater than your alleged, I don't know if it's a little g or big G, because I don't know that kind of stuff, than your gravity.
I believe that you don't know that kind of stuff.
There's no pulling. Yeah, and I made that clear, and I don't need to know that.
So don't talk about electromagnetism, because you don't know that topic.
And yeah, you've got destroyed on it. You don't want anybody to talk about it.
No, I'd be glad to go over it with you, but I don't think it's your topic.
I love watching you get owned.
I don't think it's your topic.
You know what? This is, one thing that just kind of depicts the whole thing. Like, not that I wear these things every day, but this shirt that I have on that you're trying to censor, my truth related shirt, and your Rick and Morty shirt, it just exemplifies, like, who's the Joker? Who's the one with truth on their side? Who's the one that cares about it? Who's the one that's defending the government and the evil lies that have suppressed
nothing to do with the government.
Killed so many?
You don't need the government to go figure out the shape of the earth.
Oh, you're right. You're right. There's nothing to do with the government. No.
All right. So what causes the pressure differential inside a sealed container?
I already told you. I don't know.
You don't know.
I don't
All
know
right. Well,
that
there you
science.
go. You failed.
I didn't fail anything. You didn't change.
I'll tell you, it's
You
not
didn't destroy
electromagnetism.
reality because of me
It's
not
not
understanding.
electromagnetism.
I didn't suggest it was.
You certainly did. Yeah.
No, I
said
didn't.
It was. You said it was magnetism,
No, I
then you corrected
said
yourself to electromagnetism.
No, I said the electromagnetism, even that is greater than your alleged gravity, and combined would not,
charges
if
are
we
equal.
did not have a firmament, would still not hold everything to the earth. It would still disperse and go out into your alleged nothingness. I did not say that it was magnetism that kept it into the containment. Never. Go back and watch this video like you need to do with every video when you've been destroyed. When you've been destroyed.
What accelerates things down?
My understanding, which seems to make a lot of sense, is buoyancy and density, along with the slight negative charge of the earth.
So if an object, this is according to Coulomb's law, if an object has a negative charge, then the negative charge of the earth that you claim should repel the object. It just takes a very slight negative charge to accelerate it upwards then. That doesn't happen.
There's a lot of things that don't happen with your reality.
This is yours. This is your claim, not mine. Your claim.
I could go on and on and on all day with your claims. I could claim.
Yeah,
you think that we
I'm
have
just
a
waiting
remote
for you to
control
back
car
up. I'm waiting for you to back up your claim.
Away.
What causes things to go down?
30 million miles away.
Well, you ran away from that one pretty quickly as soon as I brought up Coulomb's law. Coulomb's law. Coulomb's law says that a negatively charged object, according to you, should accelerate upward.
Negatively charged object. Let's say that to the guy that's a nobody who admitted from the beginning, has admitted over and over that he does not bring any science or maths or anything
I believe you. Yeah, you certainly don't.
Okay.
Yeah,
so
you don't bring any science or math.
All
you bring is blind faith.
Because you can't defend against
all you have is blind faith. Yeah.
No, we have the people like Witsit could destroy you. These other people have destroyed you many times.
Witsit runs from me. He won't talk to me.
Whatever. You're a joke, dude.
He won't talk to me.
Joke.
He doesn't understand electromagnetism.
You're evil. You're
at all.
Evil.
All right. Why do you have to go there? Why do you have to go there? Because why do you have to be such a douchebag? All right. Well, tell you what.
Douchebag. You've had enough because I destroyed you. You can't.
All right. Oh my gosh. What a piece of crap. What a piece of crap. How can that person exist and not be in asylum? Yeah, absolutely belong in an asylum. What causes the downward acceleration? Buoyancy and density. Buoyancy is upward. Density is not a force. Doesn't help you. And electromagnetism doesn't help you. All you need is a very slight negative charge and it should go up according to your claim. You don't have an answer to that. And then you bragged about not having an answer to that. Good job. You don't have an answer. Everything you said was a blind faith religious belief. Everything. Started with, there's no pictures of the curve. Show you pictures of the curve. Nuh-uh. Yeah. Oh my gosh. So yes, I'm sure he'll come in here and do a Derpy 33. Feel free to treat him appropriately. Wow. What a piece of crap. Yeah, read the room too. Note the topic that we're talking about and just stick to the topic. Okay. Let me find where I was here. Okay. Serenus1 says, I already said that one. AJ Treg says, thanks for a welcome break from the more serious things going on this planet we all live on. I try, I come here to get away from that stuff too, right? It affects us all. I want my friends to be safe. I want people to be safe. I want the wars to stop, please. That'd be great. But I know it won't. So while that happens, here we'll just have a little time of enjoying something else. laughing at something else, and then go back to that. You know, we you can't ignore it, but you know, while we're here, leave it outside, leave it at the door. So okay, MK Ultra, that'd be Mini Karen, has a member super chat, but no message. Thank you for that, MK Ultra. Just a Messenger says, if you talk to him again, I will send you some dressing for all the heavily scripted word salad. That was a very long 10 minutes. Gotta light a flurf. In the distant future, after the heat death of the universe, Bev will be floating through the void, repeating to himself, level is horizontal. Oh, no kidding. Peachy Tony says, time dilation effects observed in particle accelerators correspond exactly with the predictions of special relativity. Yes, and what would his response be? Space audits. I don't know. I don't know what he probably would look up some thing that was sort of related but not quite, and claim that was something. Anyway, Cyberdyne Big Toe says Jeranism isn't as fun as Onism, and only Jeranism makes you go blind. Oh yes. And does Jeranism give you hairy palms too? I had to look it up. Onanism, not onanism. All right. Serena's one says when using up facing camera, turn ceiling fan off. Well, I just had to turn off his camera. And for reference, censorship in the grand scheme is the government not doing things within anyone's particular purview. Censorship is completely accepted and should be done in extreme instances, right? So yeah, on this channel, the message that you were trying to put on your shirt, not welcome here. It's not true. It's just, again, you being dumb and then coming out in different ways, right? Live music, Greg. Just to be clear, the internet has enabled you, Greg, as the village idiot, to find and connect with a global community of village idiots where you can all tell each other how smart you are when you're just actually really stupid. So, all right. Serena's one says, old enough for gray hair is old enough for manners. He didn't have manners. MK Ultra, how does him having other pictures mean this isn't a picture of the curve? That's it. Exactly. That's exactly right. And so if you brought up a picture of the flat that was from 30,000 feet, sorry, that doesn't relate to this 46,000 foot. If you brought up a picture of the flat from 46,000 feet, well, you wouldn't. And that's the important thing. What flat earthers, they talk about high altitude balloons and they make claims about how flat they think it is. But when you actually look at the balloons, the full video, they are one of two things. Either a rectilinear, or sorry, a fisheye lens, GoPro lens with barrel distortion, and a very select portion of the video where the horizon is below the center frame, so that the barrel distortion removes the actual curve of the horizon that's there. And you can see those. There's the giveaway. You look at the far edges of it and they curve up a little. If they curve up a little, and then, because the camera moves up and down a little bit. So as it moves up and down, you'll see those edges. So, One of two things. The other is it'll be a rectilinear lens at 120,000 feet, and it'll show you the curve. They don't want that. They don't want that. They only want the one thing that supports their pre-selected conclusion. So yeah, finding a photograph of the curve isn't negated by finding different photographs of flatness. You need to analyze all of them, right? He didn't want to analyze them. He did in the end. He did say okay. He wanted to move on. I'll give him that, but what a douche. 3 Ron says Greg must be awesome at dodgeball. Yeah, well, the thing is, he's the guy. He's the guy who you hit with a ball right in the gut. He's like, nuh-uh. That's it, right? And then somebody else, while he's arguing, he hits him. Somebody else hits him. He just gets pelted with balls over and over and over. And he's like, you didn't get me. You didn't get me. That's it. That's Greg. Aaron Reese, a spherical light diffuser. Try a disco ball. Oh yeah. Melodic Lyrics says our guest is dressed like a Mormon. I think they're more white, like a white shirt with a little placard on their pocket, right? Just a Messenger says no pics of curve. Here's one. Nuh-uh. Gotta light a flurf. Yes. And let me review, because he didn't like it. This particular one, and if it's on my website, mctoon.net/curve, you can get to it that way. All right, I'm going to set this up, because I think this is something everybody can look at and use. You know, it's Wolfie did it. Thanks to Wolfie. All credit to Wolfie, right? So, all right, here is. Oh, let me get it a little fixed here. Here's the curve. mctoon.net. Actually, it's called Photos of the Curve. This is the one I built for what's his name? For Mark Sargent. So these 3 photographs I took, it's of a video from Wolfie, and the video is right here. Wolfie took this video. There we go. So here's the video from Wolfie, and he pans the camera up and down, and you can even see it can see the inside of the plane there, right? So when he pans it up and down, you know for certain that it's not the camera that's adding it, because the lens is the same, or the curve is the same direction above, below, center. So then the flat earthers are like, oh, the airplane window creates a curve. Here is Wolfie's video using the same camera through the same windscreen in his right there in the hangar. So on the ground, you can see this one bar is curved and the bottom one is straight. So Wolfie goes inside the plane. The curved bar is still curved. The straight bar is still straight. And then he even gets a left to right compression of it. Where'd it go? There it is. From Where's Wally? So there you can see over on the side, like right there, right over on the side. He's has a left-right compression. So if you like to look at that, you can see the straight is straight. The curve is still curved. Again, that's right there on the page. Links right to it, right? And then, if you're going to claim that the lens is making the effect, well, Wolfie did that by using this straight line, panning the camera up and down. So top of frame, center frame, bottom of frame, the line is still straight. So all of the flat earthers' attempts at rejecting this are totally destroyed. Every one of them. They don't have any other thing. So then what is the one thing that they go to? They're like, oh, Neil deGrasse Tyson said something. Neil deGrasse Tyson, who says that the earth is a globe, who wasn't talking about this observation, who did not bring any analysis to it. Well, guess what? We have an actual analysis. Neil deGrasse Tyson was wrong. don't care. Just because you think he's awesome, flat earthers. I get it. You love Neil deGrasse Tyson. I don't care. He's wrong. So here's the analysis of it. Thanks to Walter Bislin. The horizon matches the prediction of the globe. There it is. What are you going to do? So pan is left, right. You're right. Oh, sorry. Stringer is one. Pan is left, right. Tilt is up and down. And when I said that, you know what I thought? JM Truth. I'm going to get this wrong. This JM Truth, the expert in everything, gets it wrong. All right. I don't claim to be an expert in that. So give me that grace there. Okay. I'll go back. Steve 6464 says excuses. That is definitely what he has. MK Ultra says just remember what he has, logic and reason. He was short on that. Shovelhead Steve says this clown is what mental illness looks like. And yes, Greg, you are what mental illness looks like. You definitely are. Very sad for you. Eric Burns says he must ride Cece's short bus. Yep. Cretan Ball says this anti-Semitic POS is clearly mentally ill. Yes. Mentally ill. Let me say it again, Greg. You're mentally ill. Greg Johnson, you are mentally ill. Maybe somebody wants to go find Greg Johnson in Houston and check him in to the asylum down there. CN Videos has a 100 NT dollar super chat, but no message. I don't know what 100 NT dollars are. I'll look it up quick. NT would be New Taiwan dollars. So thank you for that. It's about $3.12. Thank you for that, CN Video. Tara Dickoff, love that, says proof that we really drastically need to improve our mental health here in the U.S. Seriously, this guy's the definition of mental illness. He is unwell. Yeah, I can't imagine that he has close interactions with people on a regular basis. There's no way. Because if you acted like that at work, you're out. It doesn't matter your job. If you work with people, you're out. You just can't be like that. Certainly, I can't imagine him having family. And, it's super common. Flat earthers are estranged from family sometimes before they get into it. Significant amount of the time, they are estranged from family by the time they've been into flat earth for a while. It destroys relationships because it's all encompassing. It's a virus that affects the brain, and it ruins so many relationships. So, PhD Tony says data sets confirming Earth's geometry, celestial navigation, astronomy, SLR, GNSS, VLBI, satellite imaging and comms, and cartography and geodetic surveying, distance calculation, seismology. Greg's wrong. Yes. Greg has denial. The globe has all of those things. All of those are big deals, right? People work their entire careers in those fields, and it relies on the shape of the earth being known. To just hand wave it away for being out of ignorance doesn't do anything. It's not impressive. Silver Phoenix Rising says live music is clowning himself with his derp. CN Video says how to turn a flurf into an incoherently babbling mass of protoplasm. Just show him the curve. It has a way of forcing them to lie, right? Because they pre-reject, and then you show it, and you're like, "What's there? What is that?" They don't have much. For some reason, very rarely he let that one. He accepted that one. I don't know why. They rarely accept it, but he did. Round Thinker says, let me guess, this guy supports Hamas these days. I don't know. He might be in a conundrum because a lot of the time they are, people like him are of a certain political persuasion too. Extreme. And it doesn't include liking people like Hamas. But it also doesn't include liking Israel. So maybe he's ambivalent to the whole situation. I don't know. Steve 6464 says, "Seek truth, speak truth. Now that he is back, got married." Yes, I saw that. I saw the pictures. I saw that he was getting married. Super excited for that. Think about that. It ruined his relationship. Seek truth, speak truth was a flat earther, and it damaged the relationship with his lady. They broke up. He left flat earth. They got back together. Now they're married. That's so happy. So, Flat Earth is Nonsense says the nervous laughter took over and he had no control over his own sickness. Yes. All right. PG Tony says your guest makes a compelling case that some people, I use the term in the loosest possible sense, shouldn't be allowed to access plasticine without strict adult supervision. Seriously, I think about this because of my job, blocking malicious emails. The internet has enabled dumb people and bad people to reach out, to have more of a platform than they ever would before. Without email, the people that want to scam you out of your money couldn't just get to you in the United States, in England, in wherever you are. They couldn't get to you, right? They're a lot of them are in third world countries. They'd have to send a letter. There was nothing. But now, for cheap, they can get into your inbox. They can put a message in your inbox. They buy a list, pay a service to deliver them, write them up. They can do that. It lowered the bar so much. It's sad. It's the same thing for idiots, right? Before, this guy, Greg Johnson, would be the babbling idiot in town. People would say, "Oh, yeah, I ran into Greg Johnson again. He was over yapping about that same crap he does every time. Oh yeah, I saw him the other week too. Boy, he sure belongs in the asylum. I know, but they don't want him in there because he can feed himself. But now he can get on the internet and he gets a platform to spread his nonsense. So anyway, Serena's one says, can't have a sealed container without a seal, and then an emoji of a seal. Oh my gosh. PhD Tony says, does your guest mother have a history of mistaking thermometers for straws while pregnant? Thermometer would have mercury in it. PhD Tony again says, you can see why this guy doesn't think survival of the fittest is a viable scientific theory. He'd have never made it out of infancy if it were true. And yeah, I mean, survival of the fittest has been turned on its head. It's brutal, right? But there's an awful lot of people that wouldn't have made it. Dumb people certainly wouldn't make it, right? In a pure survival of the fittest. Somebody else is feeding them. Dumb people today, but dumb people without that wouldn't make it. Certainly wouldn't be able to get to the age of reproduction. Shovelhead Steve says he don't know stuff, but is happy to argue he does. That's definitely was one of his things. Jiffy Jiffwald gifted 5 memberships. People, make sure you thank Jiffy for that. String News 1 says space him. That's an option, right? Someday when space travel is more prevalent, maybe we could just say, hey, you can't send your Tony, you're gonna hate it. You can't just send your criminals down to Australia. We don't. They put a stop to that a while ago. But let's make a space station just for the idiots. Flat Earthers, you get to go up to a space station. It's a one-way trip. You get to go up there and then hang out in there. We'll just we'll send a bigger unit, right? And then you can go hang out in there. We'll have 75 of them, and that'll be it. So. Gowden's Raber. This is it. In these days of internet, all stupid group of like-minded gurs, they find their safe space for the good or the bad. Yeah. It's empowered the spreading of dumb. I don't know. It's a sad reality. I'm doing my part with email, but tell you that the 9/11 stuff, when that first video came out, Loose Change, I watched it right away. In the video, I'm like, oh, they debunked themselves in the video. Let me tell you. In the video, they have video. They show some footage of the World Trade Center being built, and they show in the Loose Change video. They show these large girders that were multi-stories tall, that they put together and then they riveted. So they riveted here, and then 5, 10, whatever stories up, they riveted another one. So they have these really long steel girders, and they're riveted and then encased in concrete. When the towers collapsed, right, and they're coming down, and there's this path of destruction. There's a path of the destruction hits a floor here, and then somewhere lower, out a window shoots a whole bunch of dust and stuff. What happened is there's a girder. It hit the top of the girder that's here, right, like this, right. So, and right here, the rivets were shoved down. Right, so this whole rigid girder got hit by the stuff hitting it, falling on it, and then busted out the rivets, encased in concrete, and that shot out the windows. They debunked themselves in their video because they showed that. So, I mean that's how it should have ended. A critical thinking person should have seen that and said, oh, that wasn't explosions. That made sense. Nope. All right. Jiffy Jiffwald says, I gave you a membership for every brain cell this guy has, +5. Coincidentally, he gave 5 gift memberships. Keith Cooney says, I challenge all flat earthers to set up an equatorial mount telescope properly and then say how it doesn't prove a globe Earth or work on a flat one. Expecting them to understand how an equatorial mount works is a high bar. People that don't do astronomy don't know what an equatorial mount is, and it takes a little bit of an initiation to do it, and you have to have a little bit of an understanding of the geometry. But flat earthers, we know going into it, they don't have an understanding of geometry. So expecting them to understand the geometry of a equatorial mount telescope that's a high bar. They can't do it. They're not smart enough. They're just not smart enough. So, when you're like, well, how does it work? It just does. That's all they say. That's all they have. So, all right. PG Tony again comes in and says, I think it reflects well on our society that we can find constructive uses for flat earthers and their ilk as reactor shielding, if nothing else. True. Yeah. I mean, somehow you have to soak up all of those radioactive particles. Jiffy Jiffwald says Ocean Gate should make the shuttle to send them up. Oh my goodness. So people, thank you. Thank you for this. It's been a while. How far into it are we here? Let's see. I don't have it. Hold on. 3 hours and 54 minutes. Woo! So I think I will take the clip of the debate with Alan, and I'll post that separately. It doesn't get the live chat, unfortunately. So that's the drawback of doing that. And I didn't put it on screen, or did I? I did have it on screen for most of it. Yeah. So that'll be a fine. You can read it if you zoom in on the screen a little bit. So anyway, yeah, I'm not going to talk about 9/11 right now. It's so easy. It's so easy. All of their stuff is easier than Flat Earth. But Serena's won $2 for the Temple of Tune. Thank you for that. Okay, I've got I don't have anything booked for next week yet. I am planning to have a response to Dearth. I was going to do a response to Dearth thing on Dearth, talking about the school classes that he was speaking at. But instead, I'm going to probably respond to his video. So I did that video exposing him and calling out his lies. Offering him $10,000 to find some photographs. The one photograph that he claimed was on NASA's website. He did not do it. But he did a video responding to it, which I found very strange, because he in the trailer to that video, he covered my challenge to him, and his followers, 2 of them I found, were like, he's going to win $10,000. They didn't say that after the video, because he didn't even try. He just basically said, if you haven't watched it, you don't need to. I'll cover it. He said, I know I saw it on NASA's website. That's it. That's all he has. And he goes through a handful of different ones. All these memes. He pulled up all of his memes of this is NASA, this is someplace on Earth. All of them, where one's red, one's not. He went through all of them. He's like, I know I saw one of these. No, he didn't. A critical thinker would get the URL to the one on NASA and the URL to the one elsewhere. You'd get both of them. You'd save both of them. You'd get screenshots of them on the website. You'd get the URLs to them. You'd go to archive.org. You'd have them be recorded in archives.org. You'd do something, but no, they don't. They do none of it. They see the meme. They blindly believe the meme. They repeat the meme. That's it. Gotta light a flurf. It's a lie. Telling a lie is a lie. Telling a lie makes you a liar. Intentional or not. Right? It's worse if it's intentional. And I think Dearth is intentional. All right. Let's what did rounds 4 hours already. All right. Yes. How you doing, Round Thinker? How you doing? Oh, hey. he asked, do you want me to join also? At 10:17, it's now 11:46. Hey, if you want to come in for a minute, I would love to say hi to you. I tell you, there are some people that asked me how you're doing. They're like, is your friend from Israel okay? And I'm like, I checked, he's good. So there we go. Send me a link, he says. All right. All right, I don't want to get too much. I don't want to, yeah. We'll keep this as a distracted thing, right? We're not gonna discuss other than just making sure you're safe. So, all right. All right. Sent. Zoom link sent. And I don't know if you can get on camera or not where you're at. Let's see. Anyway. Yeah, and it's a distraction. It is. So all right. Here we go. He's joining. Oh.
Yeah.
All right. Distraction. Oh, you gotta pause the or turn off the. Right.
No, I have a blank wall behind me.
No, the YouTube video.
Oh,
And I'll get your picture up here. All right. I don't have to hide like I had to with that derpling there. All right. There we go. Welcome, Round Thinker.
hello.
I see a little bit of a uniform there.
Yeah, I am.
Are you on base?
I'm in base. I'm finishing a shift. It's almost 8 a.m. I'm in shift since midnight.
Wow.
Going in about 10 minutes.
This is funny. Lord, it's probing time, says Mini Karen, I think is correct, but lives in Israel. He's been in the chat here. He's MK Ultra. Lord, it's probing time. Yes, and so I checked on Round Thinker. I checked on Mini Karen and another person on Facebook, to make sure that the 3 people I know are okay. And then what's the guy the flurf, Israeli flurf?
There's a lot. Which one you're talking?
I've been on his show, Esh News.
Oh, near Shoshani.
Near Shoshani. You said it too fast for me to see the space between them. Yeah, he I saw he posted somewhere on Facebook. So he's a flurf. I was going to ask him, but then I looked and I saw he was posting. So anyway,
Still goofing around. It's
yeah.
regular nonsense.
You're finishing the shift, like an all-nighter shift?
In 10 minutes, my replacement comes.
So has it been quiet there at least?
The night was no tasks.
Oh, that's good. That's good.
You only see the blank wall behind me, but this entire war room is interesting.
Yeah.
Like 60 inches TV with all the data and that side. Like a huge paper on that side and 2 maps right in front of me.
Wow.
And
are they Gleason's maps?
No, they're the maps of the small part of Israel.
So not the one that J.S. Christopher made from Morton College.
They can claim that since the maps are flat, so then the regular nonsense. Yes. Nice.
There, MK Ultra is this. He said near Shoe Sunny. He's messing with the guy's name, and Shoes Honey.
Yeah, I see that in the chat.
So I was. It was probably 3 years ago. I was on his channel with,
Adam
Meakin. The one time I've spoken with Adam Meakin, yeah. Silver Phoenix Rising says, "Stay safe, Round Thinker."
Yeah, I see. I can't respond to all of them. So thank you to everybody who's cares about me. I'm fine. My family is fine. Thank you all.
Awesome. Well, anything else? I'm gonna wrap it up here in a little bit. So
No, we're here. It's good for now. the situation back in Gaza is horrible.
It's a mess.
But
Yeah.
I hope things will get better soon.
All right. Awesome.
Thank you.
Well, yeah, thanks for popping in. I'm gonna just a second. I need to. There it is. I always have to do a Shah sum on my my outro video. Make sure it's loaded.
Okay.
Cretan Bull says, I love that idiot Greg is probably melting down because you have an Israeli on. Stay safe, my friend.
And a Zionist, a soldier, no less.
Absolutely. He had a lot of problems. And oh my gosh. Well, stay safe. Definitely. And if anything to make Greg more upset makes us all happier. So, all right. We'll see you. We'll see you later. Keep me updated.
Okay. The regular messages.
Ooh, I hear somebody talking. All right.
Yeah, guy came in.
All right. Cool. We'll see you later.
Okay. Bye.
All right. Yeah, that's I do a Shah sum because it has to read every byte. Ion says cat into dev null. I don't need a cat into dev null. All right. King Cruz says, Ron Thinker, for real, stay safe, man. Thanks for your service. Take it easy and rest up. Yeah, he had to sorry. He had to pull an all-night shift. He told me earlier today that he was gonna have to do that, and this might be his distraction for while he's doing stuff, because overnight probably wouldn't have a whole lot to go on. So anyway, Round Thinker, take care. Everybody else, thanks a lot. And I'll have something for you next week. I might Friday with Flatzoid. Can you handle it, people? Can you handle it? All right. We'll see you later. Thanks.